Dear colleagues and students, on behalf of the Rector of the University of Urbino, Professor Giorgio Calcagnini, and the organizing committee, I have the honor and the pleasure to introduce you and welcome you to the third edition of the PhD Days. This event has been organized by the Biomolecular and Health Sciences course at the Department of the Biomolecular Sciences. Here we are in this magnificent aula magna of the campus Mattei. This event has been highly programmed and desired by the different courses of the PhD that are ongoing at our Atheneum. And we have the Biomolecular and Health Science here, Global Studies from the Department Economy, Society and Law, Research Method and Science and Technology from the Department of Pure and Applied Science, and the course of Humanities from the Department of Communication Science, Humanities and International Studies. These courses will be presented by the coordinators in a few minutes. Before starting, please let me thank all the people who made this conference possible. First of all, I have to thank all the students, of the PhD students, that even yesterday and this morning asked me to ameliorate the presentation for the Best Presentation Awards. And as well as the representative of the PhD students, Arianna Scardino, that today is in Leuven. So I don't know if Arianna is listening us. Ciao, Arianna. And the students from the organizing committee. The idea of this event is thinking about the needs of the PhD students, and we would like to involve them more and more the next year. And even them, they ask for an increase in salary for being involved in this committee. Just to think I'm speaking in front of the coordinator of the course. The teaching manager, Giulia Rivas, who accepted the risk of this job before understanding the real committee of the involvement in the organization of this PhD course. And the event committee, we have a different committee from this year. The event committee is composed by the professor that accept this rule. And first of all, Emanuela Frangipani, that she always is very active when it's possible to collaborate in research and in educational activities for the improving of our course in this program. Professor Andrea Pompa, that also had the great idea of a journal club that is very well appreciated by the students first. And also colleagues that are working online right now, such as Fabrizio Perroni, Professor Perroni, and Professor Mirko Fanelli. And from teaching committee. From the teaching committee, Professor Francesco Lucertini. He has, I can say, the rule has rational management of education for students and for colleagues. And he's the ones that find solution when we have some complex problem. And I'd like to thank the communication office, the webmaster of the Atheneum, Dr. Donatello Trisolino and Dr. Nadia Bocconcelli, for the support in templates and organizing the social network, but also for ideas for communication science, for the slogan, explore, share, inspire. We are trying to work together, and we had, of course, the help before by the coordinator, Professor Marco Rocchi, and today by the new coordinator, Professor Ferdinando Mannello, that said, yes, we can, more or less, facing the ideas, proposals from the organizing committee for the success of this event. So join us this day for discovery, discussion, and inspiration, all things important that provide a unique platform for sharing data, exploring innovative ideas, and inspiring attendees. Here we have from the governance, Professor Vieri, that I asked to come here just for his greetings. Thank you.
Thank you, Elena. Good afternoon to everyone. I'm here to bring you the greetings of the university, and it's a pleasure to be here in the Aula Magna that we renewed recently. So I think that we are, well, the university is proud of it. And I see a lot of young people. You are the present, and I hope for many of you the future of our research. I read the Explore, Inspiring, and Share. These are crucial work. Just I don't want to waste time, but have you seen you are in a renewed building? This is only the half of the work. Quickly, you will find here new bulldozer to renew the last part of the suggest of the campus. So I think that the work will start before the summer break. So I think at the beginning of July. But the university invested here up to now more than 25 million of euros. So a huge investment. And in the last year, more than 4 million euros of instruments are located in the structure for all of us, and we have to take this occasion to use this instrument. And I think this is important, and so relating to the three words, this is a very important word, because only just thinking to the COVID, I think that we thought how much is important to share our information, our studies, and so speaking to the young people, don't be jealous of your research, of your ideas. Speak with your colleagues, because this is crucial and very, very important. And thinking to my PhD student time, coming here from home, I was reflecting that it was for me, but I think for you the more enthusiast time. And I was young, but also I was full of ideas, and this is enthusiastic of my work. The heavy of the work was nothing in that time. So take advantage of this time, because it will not come back. So good work, a good afternoon, but first of all, speech among you, because this is the very important things. Thank you.
I asked Professor Mannello to come here as a coordinator of the Biomolecular Health Sciences course. Thank you.
Thank you, Elena. Thank you to all. I have the pleasure, first of all, to read the email from the Prof.ssa Liana Lomiento, Rector Delegate for the Higher Education of the University of Urbino. It is a great pleasure today, in my capacity as Rector Delegate, I extend my institutional greeting to my colleagues in the PhD program in Biomolecular Health Sciences and to the coordinator, my colleague Ferdinando Mannello, who have organized this day dedicated to the PhD student. The initiative of organizing a disciplinary PhD is useful and valuable, and of course, as it is offering young researchers a significant and highly formative moment of verification and questioning of their ongoing research work. This is a process that I have been experiencing for many years, ever since I introduced the same event as part of the doctoral program in ancient textual sciences as a scholar of ancient Greek literature. It would be optimal to implement a system of annual disciplinary PhD days, which would allow for the monitoring and assessment for our students to research progress and growth in awareness and methodology. The method of scientific research is one of that we all share, regardless of whether we are researching in the humanities or in the so-called hard sciences. Indeed, I must admit that the more time passes, the more may distrust of this clear-cut distinction between the two grows. In a recently published essay by the physician Carlo Rovelli, I found an enlightened reflection that is not only suitable for describing the research of theoretical physicists, but also certainly that of many branches of humanistic research. They states, but how does one go and see with the eye and the mind? I don't believe that there are many recipes except trial and error. We trust, try, and try again. That is our only recourse. We combine and recombine in different ways what we know, looking for a combination that clarifies some things. If they impede our progress, we leave out pieces that seem essential before. We must be willing to take risks with caution. We must frequent the edge of our knowledge. We become acquainted with it, repeatedly engaging with it over an expectant period, alternating between exploration and reflection. We seek to identify gaps in our understanding and attempt to develop new concepts and combinations. Finally, convinced that of the inescapable unit of the method in scientific and humanistic research, and well aware of the joyful feeling that pervades every researcher at the moment of the discovery and progress made on the road to understanding reality, I now address to my colleague and especially to all the young scholars present here who represent the future of the research, my wish for a day of fruitful sharing and discussion from which all we centeredly emerge wiser than when they entered. Liana Lomiento. I would like to take a few minutes to express my gratitude and my suggestion to all of you, and some words to take my condition of the emotion, in this case, to all of you. Dear colleagues and students, I'm delighted as the new coordinator of the PhD course to welcome our cohort of doctoral students. The third PhD Day event is taking place at the new scientific scenario of Campus Scientifico, that all of us provide a platform to acknowledge the incoming cohort dedication, passion, and intellectual curiosity. The PhD Day emphasized the commitment to fostering academic excellence, dynamic collaboration, and interdisciplinary research environment. This is the first time for me as coordinator, and so let me show you both my strong emotion and a strong surge of enthusiasm that I would like to share to everyone today. Today we will have the opportunity to explain to our BHS PhD student to have continued the path of growth, internationalization, and strengthening of the student. Who study, teach, research, and work at our university, Carlo Bo Urbino, are fortunate to experience an environment full of young people, strongly characterized by the diversity. It is an environment full of stimuli, initiative, and opportunities, an open door for young people who come from everywhere and who began to journey here as citizens of the world. As the new international campus, where merit fuel solidarity, mutual respect, and responsibility, I believe that there are two main factors that we have contributed to the virtuous path that our PhD course has taken in the last years. The first is continuity. Coordinators of PhD course alternate over time, each with their own priorities, but also guided by a strategic plan formulated and approved by the government of Ateneo, which is inspired by the same principle: cutting-edge teaching, frontier research, and the advancement of knowledge at the same time is relevant as impactful, international, inclusive, and mobile. The second one is that the long-term horizon. At the University of Urbino Carlo Bo, our BHS PhD course, all the relevant decisions are taken not simply by evaluating their impact and consequence in the short time, by carefully examining the repercussion that they can generate over long time horizon, always with attention to the international competitiveness and the reputation of our university and PhD course. Finally, to quote an Italian predecessor of doctoral course, we need to look at the scientific challenges we face as pieces of an interconnected pieces. So, as said Elena before, yes, we can, I believe. Go ahead with the program, and thank you for the job to everyone.
Thank you from the coordinator. I'm calling here Professor Frangipani. We start from the first open speech to the most brilliant part, because it's time for invited speaker and you as a PhD student. Thanks, Mannello.
Thank you, Elena. Good afternoon, everybody. I'm really honored to be part of this event today. We have said it many times, getting a PhD is so much more than getting a terminal degree. We do believe that it is a process and a journey about the pursuit of knowledge, but especially about personal growth and discovery. So driven by the love for new ideas, the purpose of a PhD thesis should be to add something new to your field of expertise. And now to do so, you need to ask new or different questions, and you need to approach subjects from different perspectives. In this way, through research, you will eventually succeed in filling a gap in your discipline. So as part of this journey, sharing your research and discuss it with peers is a fundamental learning opportunity to get feedbacks on your research, being inspired by others, and build up your own collaboration network and see what other people are working on. Today's conference aims to connect PhD students from different research areas, develop interaction among participants, highlight recent scientific contribution, and illustrate the wide variety of research conducted at the Department of Biomolecular Sciences at the University of Urbino. So today we have invited a keynote speaker that will present his research, and then BHS PhD students will have the opportunity to share and present their work as abstract presentations and posters. It's a very busy day, so we should start. Oh, I'm sorry, yes. Before we start, I have the pleasure to invite the coordinators from the other PhD courses who are here to join us, or, yeah? Ah, okay, yes. So I hand you over to Professor Antonello Zanfei, who unfortunately couldn't be here with us, but he's online.
Thank you very much. Actually, I am sorry not to be able to be there and to stay longer than a few minutes after the the intervention I will make. Unfortunately, there are several other commitments I have, but anyways, I consider this a very interesting event. As Professor Lomiento said, it is a disciplinary PhD day, which will be focusing on biomolecular sciences and highlights the role of this research field in biomolecular sciences in the context, more general context of PhD programs that are offered by our university. So why am I talking then? Well, actually, I'm talking because I think this formula could be replicated also in other disciplines, probably not this year, but it is absolutely something that could help have the knowledge of what is being carried out in different fields spread also beyond the specificity of the PhD program per se. So the idea of letting everybody know what everybody else's research is actually about is something that helps having that discipline known better and at least to raise interest in young researchers in those fields. The research program I am coordinating, which is Global Studies, is actually an international PhD program at the intersection between economics, politics, sociology, and law. And it was actually founded in 2017. We are now in our 7th edition, and we are organized along two streams. One which is actually on economics and politics of globalization, and the other on society and law in a global context. So we are actually analyzing different aspects of globalization in alternate years. And what we do, which is pretty much convergent in the idea of the PhD day, is having a sort of PhD sessions that we organize every year over 4 days. And over 4 days, we have presentations by our students, their own research activity, which is very, very fruitful and interesting. We have several discussions also interacting with our PhD students. Our PhD is pretty much international. We are having about 300 hours of teaching every year and about 40 to 60 seminars in English that are offered to our students. And most of our staff is actually teaching staff is coming from different institutions, the majority of which is international. So I think we are moving pretty much in the correct direction, and I see that also the other PhD programs offered by our university are moving in this direction. So I hope it'll continue in this way. Okay, I don't want to steal too much time to a very interesting and dense program, so I leave the floor to other interventions. Thanks a lot.
Thank you.
Thank you very much, Professor Zanfei. I now hand you over to Professor Luca Lanci, who's the coordinator of the ReMeST PhD course.
Did you hear me? Yeah. So, okay, I start with some apologies for not being there with you. So let me shortly introduce the doctoral program, the educational doctoral program of the research method in science and technology. Research method in science and technology is an innovative, international and interdisciplinary doctoral program which pays attention on foundation principle and methodological tools in scientific research. And this is presented across different disciplines, applied disciplines, yes, that mainly reflect the thematic areas of the research area of the department, of the SPEA department where the doctorate is based. So this area rather wide. They include chemistry, earth science, informatics and mathematics, and physics and philosophy of science. And within them, the candidates have the opportunity to choose the research project that fits better to him, to his interest, his or her interest, and to deepen the research capability and activity within a project which includes also national and international activities. So this is I see this as a very interdisciplinary project, and it maybe fits right even if it's not biological but it gives an idea of how well the multidisciplinarity and heterogeneity can be taken as can become a positive achievement in a doctorate program. So generally speaking, the doctoral courses aiming to provide skills and knowledge which are necessary to approach research activity and in science and technological field. So and this is done through the interdisciplinary nature of the doctoral course. And so I like to think that students of the ReMeST, the research method in science and technology, would also be able to enjoy the presentation or the topics that will be presented today actually in this event, even though they're probably not exactly their research field. Yeah. So I think, yeah. So overall, what we expect from a doctoral students is that it can define is a educational and scientific skill through transversal or techniques in various fields, and this is I think the main, or maybe it's not the main, but it was an important point of today's event. Well, thanks a lot.
Thank you very much, Professor Lanci. I take the opportunity to thank all the coordinators who have joined us today. Okay, so let's start. We have the honor to have here today Dr. Davide Clementi, who is the National Deputy Secretary of the Association of PhD Students and PhD in Italy, the ADI, Associazione Dottorandi e Dottori di Ricerca in Italia. Davide is a subject expert in comparative legal systems and other comparative law disciplines at the Department of Law at the Università degli Studi di Macerata, but he's also affiliated with the Department of Political Science at the Università degli Studi Roma III, where he is affiliated to the Interdepartmental Center for Studies and Documentation on China and East Asia. Actually, he's also spent a semester in Beijing in China, and is currently developing a research project on the implementation of innovative technologies in the Italian creative and cultural industry in the context of the legal system and markets of the Asian countries. However, today he's here because he will be talking about the current challenges for PhD candidates in Italy and how to overcome them within the national scenario. Thank you very much, Davide, for joining us today. Please, the floor is yours.
Dear Calcagnini, Professor, Dr. Pietro De Angeli, dear colleagues. Good afternoon, and thank you for inviting me to this event, which underscores the University of Urbino deep commitment to listening to and promoting the research activities and of its doctoral candidates. It's not as usual as we think. I'm here today as a representative of ADI, the association that for over 25 years has been advocating the rights and interests of PhD candidates and graduates in Italy. We strive to do that both within and outside academia. Over the past few years, the doctoral program in Italy has undergone what one might call genetic engineering, pardon the appropriation, Dr. De Angeli. The National Recovery and Resilience Plan, PNRR, has mandated within the context of the twin transitions to digital and green economies, an increasing emphasis on doctoral programs that guide PhD candidates toward businesses and public administration. The number of PhD candidates has skyrocketed for the first time, allowing many to access to the highest academic title awarded in the Italian, European, and global research system. Today, thanks also to the ADI's efforts, we are nearing to the recognition of the PhD degree in public administration, even in our region, the Marche, supported by a regional law proposal that should have our full backing. This is undoubtedly a positive development, but it should not and must not deter us from addressing what is not working in the Italian research system. The PNRR has attempted to engage the Italian industrial sector in research and development with limited success. According to data from Ruhi and Confindustria, only 1/3 of the funded PhD scholarships have actually been allocated. Italian small and medium enterprises were not, and are still not, structurally ready for research and development, being too small, many family-run, and not inclined toward innovation. The increase of the number of PhD graduates will thus exert enormous pressure on the academic system. This is a system already strained by the rising cost of living, stagnant funding from the so-called Fondo per il Finanziamento Ordinario for 2 years, the end of the extraordinary plan for the recruitment, and now the impending reform that the Italian government and Minister Bernini are about to implement across the university system through Article 11 of the Legge Delega sulla semplificazione. 15 years after the Legge Gelmini, the university and research sectors are now once again facing reforms. And from what we have learned, it does not seem to be for the better. On a personal note, I'm deeply moved by what Dr. De Angeli will share with us because of his research for solving ophthalmological issues. My mother lost her sight due to repeated retinal detachments. As a child, I often heard that research was making great strides. These strides are long, require time and funding, and rely on the efforts, hands, and brain of dedicated individuals. Despite being a jurist, I seek out scientific literature for any new discoveries that might solve my mother's problem and that of the others suffering from these severe disabilities. Only researchers with good, continuous, and well-paid jobs can effectively work to solve these and other challenges that humanity faces. The reform that is in front of us does not move in this direction. It speaks of junior and senior fellowships lasting even 6 months, renewably annually. It speaks of PhD graduates who at 30 or 35 are still not considered properly workers. It speaks of inadequate social and health protection. It speaks of underpaid, poorly funded system where everyone is exploited, where the lives of young, brilliant individuals are left dangling under threat of precariousness and on the anxiety of publish or perish mantra. Addis 11's report on psychological well-being reveals that PhD candidates and young researchers are more likely than the national average to experience conditions of anxiety, stress, and depression. Such stress is often linked to or caused by the extreme working condition where quantitative hyperproductivity is prioritized over a serious and thoughtful qualitative assessment of a researcher's work. The very system of national scientific qualification, or in Italian, the abilitazione scientifica nazionale, and the so-called research quality evaluations has distorted our work, turning us into citation machines and paper mills, rather than scholars dedicated to thinking, debating, and yes, even making mistakes, because research, as we know, is also made up of errors and missteps. I ask all of you and the professor in this wonderful room that is a proof of the success of the PNRR, can this system be acceptable for ourselves, for yourselves, and for your son and daughter, or your siblings and beloved one? Can we continue to fill our speeches with words of merit, excellence, and results when we do not accord proper dignity to all research work simply by applying the European Charter for Researchers, which recognizes dignity and human working condition to all researchers across the European Common Research Area, starting from the doctoral level? As ADI, we think to know the answer to these questions. It is time for all of us as an academic system to respond them now. Thank you for your time.
Thank you very much, Davide. You really brought some interesting points here. Okay, so let's move on to our keynote speaker. I invite Ruhi Anjum, one of our PhD students, who will introduce Dr. Pietro De Angelis.
Thank you so much. Well, good afternoon, everyone. I am Ruhi Anjum, a third-year PhD student. I'm here to invite one of our speakers, Dr. Pietro De Angeli. Pietro works at the Molecular Genetics Laboratory at Institute of Ophthalmic Research, University of Tübingen, Germany. He is a molecular biologist, a scientist with a deep experience in CRISPR-Cas9 projects, And interestingly, Pietro has pursued his master's from University of Urbino. And during his master's, he worked on engineering enzyme replacement therapies for creatine deficiency. Also, during his master's, he got a wonderful opportunity to join a lab in the United Kingdom at Wellcome Sanger Institute. There, he worked on various genome editing projects, and at that moment, he became fascinated. How can be a human genome manipulated by genome editing strategies, specifically the CRISPR-based systems? Then he decided to pursue his doctoral studies in University Hospital of Tübingen, and he joined there in 2019, where his project was based on applying CRISPR-Cas9 based projects, and his research was focused on Stargardt disease. This is a autosomal recessive disease which is based on the degeneration of the macula. So currently he is a full postdoc and a junior group leader, where he is supervising various PhD students, also the master students. In the past, like for 2-3 months, I also got a wonderful opportunity to work under his team at University of Tübingen. So I'm happy to invite, please give a big hand for Dr. Pietro Di Angeli to share the contributions with all of us. Thank you.
Good afternoon, everybody. I hope you can hear me well. Thank you very much, Ruhi, for the nice introduction, and thank you very much to the organizing committee for this nice opportunity. And I would also like to congratulate from my side for this big achievement of the new Suggesta. It's really nice to see this scientific hub happening here in Urbino, so really congratulations. So today I will be talking about some genome editing, specifically the work that we have been following for the past 5 years at the University Hospital in Tübingen, where we are trying to establish genome editing technologies to counteract inherited retinal disorders. However, what I'm going to tell you about can also be applied to other inherited conditions. So before starting with the scientific part, I would like to start into the topic by answering the following questions. So what is genome editing? And if there is somebody who would like just to contribute, can just raise his or her hand. No? Okay. So basically, when we talk about genome editing, we talk about means by which we can precisely change the DNA, and we also refer to that as targeted genome editing. Because if you think about that, we have been able to access and edit the DNA since decades. When you think about restriction enzymes that you are using for in vitro cloning, these are also molecules able to target the DNA, open the DNA, and then you can manipulate the DNA. However, they miss one important feature, which is to precisely do that. So if you would use restriction enzymes to implement therapeutic options, you would just end up shredding the DNA completely, which is what you don't want. We know pretty much, I guess, everybody about the CRISPR-Cas9, or at least heard about it, but it's not the first example of genome editing technologies that we have had available in our toolbox. So before CRISPR-Cas9, or as we refer to that, BC, so before CRISPR, and AC after CRISPR, and now we are into the post-CRISPR, but it's not the topic of today. We had, as two examples, zinc finger nucleases and talons that were also able to target the DNA. However, when we look at the engineering and the use of these restriction enzymes, the preliminary experiments were really laborious. The design was also demanding, and sometimes the preliminary results were not matching the expectations when you were moving towards the clinical approaches. Then we had the big revolution, the CRISPR-Cas9 revolution, and I'll give you a taste of that starting from the molecular mechanism, and then we'll look at the historical background because I find that really interesting as well. So the CRISPR-Cas9 is a molecular scissor, and it's specifically a programmable RNA-guided endonuclease that is composed of two systems. We have the factor protein, which is the Cas molecule here in green, which complexes to a guide RNA that is specifying for the target. These two elements complex together in the so-called guide RNA Cas9 complex. It binds the DNA and goes around looking for the sequences, actually the sequence, that's what you hope for, that is matching to the guide RNA sequence by complementarity. And once that's found, we have the Cas protein, the factor protein that is inducing a double-strand break. And by changing the sequence that is complementary to the target DNA, you can target and access pretty much any sequence across the genome. There are some requirements, but let's take it as if we could access all the sequences. Then, once we had the double-strand break, the editing process is initiating, because that's the starting point. The editing happens because the cells, mammalian cells we are focusing on, are detecting a double-strand break as a damage, and they have to repair the damage. And this happens through 3 main pathways. 2 of them on the left side that are error-prone. So the outcome is a repair resulting in a perturbation of the original sequence insertion or deletions that we refer in jargon as indels. On the right side, HDR, that stands for homologous directed repair, is an error-free repair pathway that basically uses a donor template having homology arms to the targeted sequence. So looking back, is not that we have made the CRISPR-Cas9 system, is something that was occurring in nature, and we implemented that for genome editing. Indeed, the CRISPR-Cas9 system is a prokaryotic adaptive immunity system that allows the bacterial cells to fight infections by bacteriophages. And the way it works, really briefly, is that you have a first step of acquisition of foreign DNA material. So the bacteriophage which inject the DNA, this DNA is recognized by Cas-related proteins, processed, chopped, and inserted in a so-called CRISPR array locus, where the information of the genomic, of the DNA, coming from the bacteriophage is stored. If the bacterial cell survives the first infection, it has the information to fight a second infection. And this happens in the second and third step, which is the expression. So the expression of the CRISPR locus happens always. And this leads to the coding of the guide RNA, so the element that is specifying for the target to target. And upon a second infection, what you have is that you have the silencing step, where the guide RNAs are combining to the Cas9 effector protein and silencing the viral DNA by cutting that. And it took us quite a while to understand that. Indeed, if we go back in literature, the first hint of the system are from 1987, when Ishino was studying a gene in the genome of E. coli, IOP gene, and they saw that there were some sequences that were repeating and that were arranged in a kind of cluster. At that time, this was just an observation because, of course, the functional meaning was not known, but it's the first hint of the CRISPR locus. So it was looking at this area here. Then in 1995, we have Mojica, who was studying other bacteria, and he saw the same occurrence. He started or tried to raise some money grants to study that more, but all of them were rejected. So he just gave up on that. However, he was the one who coined the CRISPR system together with another scientist. And CRISPR stands for Cluster Regulatory Interspace Palindromic Repeat, which is the description of the cluster we are looking into, the bacterial cells. Then we have these 2 ladies, Jennifer Doudna and Charpentier, that in 2012 published this paper where they showed that the system could be harnessed for in vitro editing. And interestingly, this was published in August 2012. Not many people know this guy. He is Virginijus from the University of Vilnius in Lithuania, who published the paper just not even a month later. Where's the date? Down here, August. No, down here, sorry, yeah. The interesting thing is that he had submitted the paper already to another journal, but was rejected. So if that had been accepted, it would have been the actual guy who discovered and probably would have got the Nobel Prize, because what they did was basically looking at the date, and these 2 ladies got the Nobel Prize. He has a lot of patents and stuff, but he is almost never recognized as the guy who discovered head-to-head the system. Then we are in 2018, when I would say, a crazy scientist, Chinese scientist, edited the first embryos, so in vivo editing. And he did that in vitro, of course, edited 2 embryos and implanted them back into the mother. And here we are in 2018, and this is when he was saying what he did, and that the 2 girls were born healthy and everything. And this was a big, let's say, drama or problem into the scientific community, because he was tried for illegal medical application, jailed for 3 years, and he had a lot of troubles and problems. And why did he do that? I will stop this. It was just, sorry, yeah. To knock out a gene that is protective against AHV, because the mother of the 2 girls was HIV negative, but the father was HIV positive. So by knocking out this gene, you make the cells resistant towards infection of HIV, so the 2 girls couldn't be infected. However, one big argument was also that today you also have sperm washing that would be protective 99.9% in the cases when the father is HIV positive. So it was just a crazy thing that he did. As said, he had a lot of problems. He's still in the business, and I'm following him on X, if you want to see what he's doing at the moment. And why is Make People Better? Because the whole story is now on Netflix. There is a documentary, so if you are interested in knowing more, you can just type this and look at that. And this is actually a quote from James Watson, who had an important part into the whole story, just to tease you a bit. Then we are in 2023, after years of optimization and further studies, when the first ever gene editing treatment was approved by first the British regulatory agencies, then FDA and EMA. And this is an ex vivo gene editing treatment, so an actual medication in this case, not illegal medical practice, that is aiming at treating transfusion-dependent beta thalassemia and sickle cell anemia. So you have patients having these disorders where the red blood cells are basically assuming this shape, and this gives problems in terms of blood flowing and pain and many other things. And what they do is to take stem cells from the patient, edited them in vivo for activating, let's say, an isoform of adult hemoglobin, and then they infuse the stem cells back into the patient, and the patient is supposed to go back to an healthy or almost healthy phenotype. So I just gave a bit of an introduction into the CRISPR-Cas. Now I'll move towards what I've been doing for the past 5 years. When I joined the Institute for Ophthalmic Research, I landed in a lab that was really much interested into splicing analysis of and characterization of inherited retinal genes related to inherited retinal conditions. And I have some papers from them. And I had a bit of a background in CRISPR-Cas, so we thought of combining the 2 technologies and trying to rescue splicing by using CRISPR-Cas. Just really briefly, what is splicing? Most of you should know, however, is an essential molecular mechanism in eukaryotic cells that is responsible for removing intronic or non-coding sequences from a pre-mRNA molecule to then generate a mature mRNA molecule that is then translated into a functional protein. In a healthy situation, this happens really precisely. However, there are instances when pathogenic variants or mutations, as you want to call them, are impairing this splicing system, leading to missplicing, which of course leads to the generation of a functional protein or no protein at all. And it's calculated that across inherited disorders, so not just for eye-related disorders, but in the whole sphere, we have around 5 to 15% of disease-causing variants affecting splicing. So missplicing can happen in different sources. We can have, like in the first case, exons, so coding sequences that are skipped during the splicing process. We can have the elongation of canonical exons into the introns, both at the 5 terminus, or, well, this would be 5 terminus, and this 3 terminus is just the reference that is of the splice site. Or what we can have is intronic retentions. So sequences from the introns that are spliced in during splicing, although they shouldn't be in there. So it's a kind of complex system. So when I started focusing on ABCA4, which is a gene responsible for juvenile macular degeneration, known also as Stargardt disease. And Stargardt disease is affecting the central vision, so image that you cannot read, you cannot drive, you cannot watch a video because your sharp vision is not there. You just have your peripheral vision that is not sharp, of course. Peripheral vision is the macula, so the central part of your vision. And it's really basically a difficult disease, let's say. And in this gene, we have different pathogenic deep intronic variants. However, one, the -557, locates in intron 36, 556 nucleotides downstream exon 37, and this affects splicing by retaining, during splicing, an intronic sequence that shouldn't be there. Then this aberrant transcript, as we call it, is often degraded by molecular cellular pathways because it contains premature stop codons. Not a really important piece of information for here, but just nice to know that's NMD that is just chewing the aberrant transcript. So what we did here was to try to design 3 different CRISPR-Cas9 strategies to try to remove the intronic sequence involved in missplicing. And what we have was a first dual guide RNA approach, where a guide RNA generating a double-strand break is designed upstream, the splicing defect, one downstream, the splicing defect, and this should lead a genomic deletion. Then we also implemented nick cases, which are kind of improved form of Cas9 that are only generating nicks and not double-strand breaks. And when you make a nick on opposite strands, this results also in a deletion. And then we implemented single double-strand break approaches where just a single guide RNA is used to perturbate sequences involved in missplicing. What we did was then to test these approaches in heterozygous iPSCs differentiated photoreceptor precursor cells to see if we could rescue splicing. And really briefly, what we saw is that for all the 3 different strategies across different guide RNA combinations, we're able to increase the percentage of correctly spliced product that you see here on the y-axis. However, an important observation is that also the untreated samples or cells were showing a correct basal fraction of correctly spliced product. That is because we were using a heterozygous cell line where the counter allele is not giving missplicing. So you always save a base of correctly spliced product. Why am I telling you? Because this is relevant for the second work that we did 1 year later, where we tried to correct splicing of clustered deep intronic variants. So again, in ABCA4, we have different hotspots. And this is an example in intron 36, where 4 different deep intronic variants are located in a sequence span of around 200 nucleotides. So from 1013, plus 1013 to 1216. So it's also clinically viable if you can find a single approach rescuing different genotypes. So what we did here was to again, generate a single dual guide RNA approach to try to rescue all of them. However, before doing that, we wanted to try to address this problem of the counter allele that can give correct splicing. So we are dealing with mutations that are really rare. So having a homozygous patient for these variants is basically impossible. And what we did was to use a control iPS cell lines to then introduce the different variants of our interest using CRISPR-Cas9, HDR mediated by CRISPR-Cas9. So this way we could obtain homozygous cell lines to work with. And then we checked if we could design a single guide RNA approach to rescue this. We did some splicing assay, but I haven't reported anything here. So this is the genotyping of the iPSC cell lines, the 3 different mutations we focused on, and then with a single guide RNA, a single approach of 2 guide RNAs, we could rescue the splicing at similar level across 3 different variants. And this is depicted here in the first 2 bars, with or without cyclohexamide, which is just an inhibitor of NMD. That's not really important at this stage. So we are at this stage. We have the therapeutic option or approach to scale up into more advanced cellular models or whatever. And as you can see, the other guys say, well, actually not nice for a publication, but it's not really viable clinically because there are different safety concerns that are still a problem. So first of all, we are using more than one guide RNA, so the chance of off targets might be arguably higher. And by generating a chromosomal deletion, you have structural aberrations that can happen. And these happen more often than what we think. It's just that we are not able with the current protocols to detect them. That's another issue. And the activation of p53 related pathways, the more double-strand break, the more p53 you can activate. And then you might argue, okay, but you also show that you have a single guide RNA approach, but these are not scalable into therapeutics because they only rely on the mutational profiles or repair profiles that are generated after the break. And these are cell line dependent. So you might get really nice results in a cell line, then you try another cell line, and it's completely different. And this is not a risk that companies can accept for scaling up into clinical approaches because it's too risky and difficult. So we went back to how the splicing works, and we took this top-down reasoning where in all missplicing cases, there are sequences that should not be in there, but they are recognized by the splicing machinery. So if we can prevent the recognition of these sequences, is there a way we can rescue splicing in a more effective and consistent way? And what we came up with is the so-called ED-splice system that stands for Enhanced Deletion Splicing Correction Editing, that is using single guide RNAs to rescue splicing. And what this editing platform can do is to induce consistently larger deletions at the targeted site. I'll show you in a second. And how did we achieve that? We took whatever Cas9 and coupled that with a 3-terminus end processing enzyme, or in other words, hexanuclease, that upon cutting should chew the generated ends to generate a deletion. And why are we interested into doing that? Because basically, as you can see here in this picture, if you can target a splicing feature or defect by generating a larger deletions by using a single guide RNA, you can make sure that this feature is destroyed and not recognized anymore. And given that we are mostly dealing with intronic sequences, if you generate a deletion at the intronic sequences, you are almost sure that you are not messing up with the function of the gene and regulation. It's not always like that, but it's an educated assumption. And we started testing the system in in cluster deep intronic variants. I just report here an example, but if you want to see more, this paper is now under review and available on bioRxiv. So we selected 4 different deep intronic variants into different genes, ABCA4 that you know already, and ASH2A, which is a gene relevant for Usher syndrome, which is a form of combined deaf and vision impairment. And it's really brutal because it starts really early, so you have even babies that are affected by that. First, the hearing comes, and then the vision problems. The way we went by was to take a so-called mini-gene plasmid. Basically, it's a plasmid that can mimic the missplicing process into cells upon transfection, so you don't have to rely on patient-derived cellular system. And we co-transfected this mini-gene with an editing plasmid with different guide RNAs to see how, if and how our system could improve the splicing. And what we saw for the last example here, because of lack of time, but again, you can check this out. Across 6 guide RNAs, we were able to consistently achieve higher splicing when using the EDCAS system, and sometimes at a really high level. Then we took patient-derived fibroblasts and tested the STRAT 4 lead candidates, 4 lead guide RNAs at the genomic locus, and all the tested guide RNAs were able to achieve with the EDCAS system more than 85% rescue in patient-derived cells. Guide RNA 6 is peculiar because it's cutting directly on the deep intronic variant site, so having these enhanced deletion features doesn't help in this case, but it's just a lucky pick. And we showed that you can generate larger deletions by doing high throughput sequencing at the genomic level. This is an example for 1 guide RNA where you see all the rates that we got out the NGS and 4 guide RNA 3 combined to EDCAS. We not only get enhanced deletion, but as you can see also highly directional. And this is really an important feature when you want to target missplicing happening at the intron-exon boundaries when you don't want to mess up with the exonic sequence. Then we have another problem. Okay, good, fancy, whatever, but what's the way to deliver these editing tools in vivo? And when we look at to the gene therapy approaches for eyes, the only option at the moment, although there is a lot of going on, are adeno-associated virus, which are really nice delivery tools, but they have a problem. The capacity of cargo is limited to 4.8 kilobases. And our system is exceeding that. So what did we do? We basically swapped SP-Cas9 with another ortholog, another RNA-guided endonuclease, the so-called surgeon, that is much smaller, and all the system then can fit into the AAV capacity. We did some structural studies using AlphaFold to optimize the linker and the conditions, and this is just a fancy rendering. And then we also went on into the engineering, because we have Trex2 here, right, which is an exonuclease, and an exonuclease has two domains, can bind the DNA on its own and also chew the DNA. And we don't want to have guide RNA independent chewing of the DNA, because that would be an off-target. So we want the chewing to be dependent only on the Cas9 combined activity with Trex2. And what we did was to identify, thanks to some structural proteins, 3D structures that were available, the essential DNA binding residues, mutagenize them from arginine to alanine, and we lost the DNA binding function of Trex2, and we are now in vitro validating this with the help also of Prof.ssa Bianchi and Filippo Tasini. So we are back to this deep intronic variant on H2A, because it's the most common one. And what we did was to see if we could rescue with the new enzyme, the splicing. We did different testing in two different cell lines, and what we saw, without going to the details, is that guide RNA3 stands out as the most effective one. Then across also the original parental surgeon variant, this is an important feature for later. So at that point, we packed the system into the AAV, and we tried to deliver the editing system with AAVs upon splicing, mini-gene splicing rescue analysis. And what we saw was that with the 3 different variants, we could achieve similar splicing correction, also with the parental surgeon variant. And we tested 2 different MOI, and this is just to show that with sufficient MOI, we can achieve up to 90% of splicing rescue in HEC. And HEC are really not easily to transduce with AAV, because you need, as you see, a lot of virus. I'm almost, I guess now you might have a question, which is, if you already get high splicing efficiency with the parental cell line, why do you need all these problems, all this fancy design to get an exonuclease in? And there are 2 main reasons. The first one is that across different guide RNAs, we can get higher splicing rescue, meaning that now when we do the off-target assessment of the guide RNA3, if it has many off-targets, we still have 3 peaks, that 3 other guide RNAs that are able to achieve high splicing rescue. But the most important point is that surgeon or Cas9-induced double-strand DNA break give rise to more genotoxicity. And basically, I introduced earlier the non-homologous enjoining. The non-homologous enjoining is thought to be an error-prone molecular mechanism, but the reality is different, and there are more and more papers coming out. And basically, what you have is that most of the repair systems, the repair profiles, are error-free. So it would recode for the guide RNA target sequence. And then the guide RNA would basically go back to cutting, and looping for many, many times, and we don't know how many times. And until you get some deletion or insertions that are not recognizable by the guide RNA anymore, then the guide RNA would not go into this loop. So the genotoxicity that is related to the double-strand break, as you hear in the news or wherever, is not really associated to a single double-strand break, but most likely to this recutting situation. And this gives rise to many problems of adverse events. So chromosomal translocation, loss of heterozygosis, large deletions, and chromosome loss, and so on. And the more you have of these, the more chance you have to get them. Whereas with our system, what you get is basically it cuts, it chews, and cannot cut again. So it's a single shot, one kill. And how we started it's a nice story, but we need to prove that in science. So we started focusing on these different adverse effects, and today I will just show you the chromosomal translocation, and then I'm done. So the hypothesis is that ED splice variants cause less chromosomal translocation than the parental Cas9 orthologs. And what we did was to introduce 2 simultaneous double-strand breaks into different genes, our H2A and LPA. And what you expect if you get chromosomal translocations is that you have the formation of these hybrid chromosomes, and the combinations are these 4 that you see here. We designed them primers to specifically amplify any of these hybrid isoforms, and we tested for amplification after the treatment. And this is the result for the smaller hybrid chromosome, where you see an amplification band for the surgeon, but not for the other 2. And we have a similar patterns for the other 3 combinations. We see some of these here, but mostly are insertions because we are using a lot of plasmid. Then you might argue, okay, but is the cut efficiency similar? It is. So by that, we can conclude that our variants are much safer in terms of introducing almost 0, I would say, at least according to this experimental setting, chromosomal translocations. And just last slide is about using the ED splice system to target a different splicing defect. So we saw deep intronic variants. And now let's see what happens if we have the elongation of an exon. So we have this synonymous, really common variants in the ABCA4 gene that doesn't cause any amino acid change. But what it does is to induce missplicing by the elongation of exon 6 of 35 nucleotides. We designed 4 different guide RNAs to target the splicing defect and tested them for ED surgeon versus surgeon. And probably don't need to comment on that because you see the remarked difference, and also on the gel down here, when surgeon is basically doing nothing, almost. For guide RNA2 we see something, whereas the ED surgeon is achieving remarkable splicing correction. And I want to remind you that the system is also able to be directional. So we are just chewing that way. Again, I have the slide, but it would take too long. So take-home message here is that the ED splice is an effective editing platform to modulate splicing, which offers increased flexibility in guide RNA design and improved safety profile. And we were able to design a molecule fitting the size of a single AAV system, which hopefully paves the way towards clinical application. And next directions will be dissecting the safety profile for ED surgeon. We have other data which I cannot show you today, but we want to go one by one to really show that the system is safer. And we are advancing the use in advanced cellular models like organoids or retinal explants, but we are looking really forward to also test that in vivo settings. So if there is somebody who's interested and wants to collaborate, come up. And we're also extending that to different splicing defects. That's it. So I would like to thank my PI, Professor Bernd Wiesinger, and the subdivision of CREXT, as we call it, CRISPR exonuclease team, that are all the people behind all the work that you have seen so far. And I would like also to advertise that we have a PhD position open on genome editing if there are master's students that are interested in that. Yeah, and it's within a Marie Curie, so that's really a nice opportunity. Thank you.
Thank you very much, Pietro. This was a fantastic talk. Very, very interesting. Thank you. Thank you very much. Is there any question from the audience? Don't be shy. Okay, thank you. Professor Stefanetti, please.
What do you think are the main challenges in terms of translations of this technology? I don't know, off-target effects, delivery, editing, long-term effects, just, you know, to allow all of us to understand a little bit more the potential. Thank you.
Yeah, thank you for your question. So I think it's gonna take really 2 hours to address all of them if we want, but really briefly, I guess the main point is, as we were discussing also over lunch with Professor Magnan, is the delivery. Because at the moment we have a nice technology, we can improve it really nicely, also with genome engineering and unbiased approaches. There are tons of different applications and ways we can reduce off targets and pick them and analyze them, but the delivery is the main issue. And if you look just to translate that into the in vivo application, most of the editing technologies at the moment are either ex vivo, just the one that I showed to you, but the most advanced in the pipelines are basically for the liver, because everything goes to the liver, so it's kind of easy. But when we want to start to target other organs, then it starts being an issue.
Yes, that's absolutely. I've actually anticipated one of my questions that was about the delivery. I was curious about the clinical trial that you've shown. I was wondering what was the delivery they used, if it was adenovirus-based or another type.
No, that was probably didn't mention that. I skipped that. That was ex vivo. So it's just electroporation
I thought it was
of
a clinical
protein.
trial already.
Not this specific
no,
one.
in the introduction. Not sorry, not about your data, but the one that you've shown in the introduction.
Yeah. That was ex vivo. But the only the other clinical trials that are going on are using lipid nanoparticles targeted to the liver.
Okay.
Or there was another one for eyes that was using AEVs.
Okay, I see. Okay. Is there any other question from the audience? We've probably discussed it already over lunch, but please, thank you.
Well, just to congratulate Pietro, really, this is fantastic. I think it's a great achievement and very likely will have a very general applicability, not just in the case you have mentioned. I have a curiosity. There is any epigenetic modification that can affect the performance of the system you have developed?
Yes, really nice question. And for sure, the editing is dependent a bit on the chromatin structures and situation. However, it does not really much affect by manifolds what you get in terms of editing. And most often what you do in vivo is to target on highly transcribed genes. Ex vivo could be a problem if you go through differentiation, yes? Because could be silent when you target that and then becomes active. But in vivo, you're targeting active genes. So they are arguably accessible, and this problem is not as relevant as it could be in other situations. Yes.
Okay, well, thank you very much. If there are no other questions, I'd like to move on. Well, first of all, let's thank Pietro once again. Thank you very much. Okay, so we're now ready to move on to the PhD student session. We will start from the first year and then move towards the second year and third year PhD students in alphabetic order. I just remind you that there's no time for questions during the presentation, but it will be time during the poster session to discuss about the data. So I'd like to invite now Riam Osman, one of our PhD students, who will chair this first year PhD student session. Thank you very much, Riham, for being here and chairing the session.
Thank you, Prof. Good afternoon, everyone. So we're going to start with the first year's PhD student session. So let's welcome my colleague, Eric Bargani.
Okay, thank you, Riam. And I also want to thank my supervisor, Francesca Lucchetti, and my co-supervisor, Maria Gemma Nasoni. The aim of my PhD is to investigate the role of nitrosative stress and endoplasmic reticulum stress in oxysterol-induced vascular dysfunction. So, oxysterols are produced by cholesterol oxidation and have been found in arteriosclerotic plaque, suggesting an involvement in the arteriosclerosis development by inducing endoplasmic reticulum stress, inflammation, and apoptosis. Moreover, accumulation of nitric oxide and reactive nitrogen species can lead to a condition known to as nitrosative stress. Nitrosative stress then can lead to protein nitrosylation. This is a modification of protein where structure and also function is modified. In a neurodegenerative disorder, alteration in nitric oxide level can affect the endoplasmic reticulum folding pathway by nitrosylation of ER stress sensor. So, however, we have currently limited data on the effect of nitrosylation in cardiovascular disease. So my PhD research aimed to investigate the role of oxysterols in endothelial dysfunction, with a focus on the potential interplay between nitrosative stress and endoplasmic reticulum stress. During the first year, we treated UVEC cells with cholesterol B, a specific oxysterol, and we have some preliminary data showing that this can increase the nitric oxide production and reactive nitrogen species production. We also detected an increased level of protein nitrosylation in these treated cells. So sechosterol B can activate nitrosative stress and protein nitrosylation in UVEC cells. We also assessed nitrosylation in human carotid section. So as we can see, we started with confirming the presence of an arteriosclerotic plaque with Oredo staining. And then we identified protein nitrosylation in this section. Future studies are going to investigate the role of the potential nitrosylated ER protein to provide a mechanism for oxysterol-induced endothelial dysfunction. We are also going to assess nitrosylation of specific ER protein in the carotid section to endorse the role of nitrosylation and endoplasmic reticulum stress in the vascular disease. Thank you, everyone, and special thanks to all the people that helped me during this first year.
Posso? Okay. Thank you, Eric. Now we can pass to Alessandro Cherubini.
Grazie. C'è il puntatore. Good afternoon, everyone. I'm Alessandro Cherubini, a first-year PhD student, and now I will introduce you the project I'm working on. This project focuses on the role of ERO1, and specifically we are trying to develop new inhibitors for ERO1. ERO1 is the endoplasmic reticulum oxidoreductase, which is responsible for the disulfide bond formation in newly synthesized proteins. And it has been recently demonstrated to play a key role in cancer fitness. And specifically, ERO1 is also responsible for the correct folding and the secretion of the VEGF, the vascular endothelial growth factor. And thus, this study aims, first of all, to develop a new compound to inhibit ERO1, starting from the AN460, which is already available inhibitor of ERO1 that actually lacks of specificity because it suffers for off-target effects. And so, at the organic chemistry laboratory in Urbino, they are developing inhibitors starting from the N460 structures and by quick chemistry, changing of the 3 pharmacophoric groups. And the second aim is to, first of all, analyze and to assess the efficacy of this inhibitor by measuring the redox state of ERO1. Indeed, here you can see that the inhibitors traps URO1 in a reduced state, and which is the inactive form of the enzyme. And later, we will do the evaluation of the cytotoxic effect of these inhibitors by MTS assay, and also by flow cytometry assay. And since URO1 is responsible for the secretion of the VEGF, we aim to demonstrate that the inhibition of URO1 will impair its secretion, the VEGF secretion, and so we will measure the VEGF secretion by VEGF ELISA after administration. And finally, we will do an in vivo characterization of these inhibitors by measuring the effect of after the administration on tumor-bearing mice in order to lay the basis for further clinical investigations. I thank you all for your attention.
Thank you, Alessandro. Now we can pass to Eugenia Ciurlia.
Good afternoon, I'm Eugenia Ciurlia. My supervisor is Professor Amatori Stefano, and my co-supervisor is Professor Fanelli Mirko. It is known that among the main threats involved on cancer onset and progression, there is the environmental pollution, consisting of different types of pollutions, such as benzene, particulate matter, and so on, that act through both genetic and epigenetic mechanisms that can be exploited as potential biomarkers. For this reason, the present study aims to set up a non-invasive approach for the early detection of cancer and for the evaluation of pollution exposure. In particular, the attention is focused on the methylation levels of specific DNA sequences that we have selected, but I will not show today because of a pending patent application, that are demethylated in cancer and then can be intercepted from liquid biopsy. Indeed, plasma contains cell-free DNA, which is a mixture of small DNA fragments released into the bloodstream after cell death, which in cancer patients is strongly increased by the presence of circulating tumor DNA that carries with it all genetic and epigenetic aberrations, including abnormal methylation. So we started from a first attempt of cell-free DNA purification from liquid biopsy of healthy donors that we ran on fragment analyzer, and we can see the fragments purified that are compatible with mono and nucleosomal DNA. So the proposed assay starts with the purification of cell-free DNA, its conversion with sodium bisulfite that converts non-methylated cytosine into thymines, and the amplification of DNA with quantitative PCR using primers designed on specific DNA targets, followed by high-resolution melting that can be used instead of sequencing as a cheaper and faster method to estimate the methylation. So we designed the primer pairs and we tested them firstly on commercial DNA standards with no levels of methylation in order to set up the optimal condition of the assay and to verify the primer's ability to discern different levels of methylation. In fact, we can clearly see the differences between the methylation curves and the expected size of PCR products. Then we tested the primers on genomic DNA extracted from normal and tumoral cell lines that we fragmented in order to get closer to the size of circulating tumor DNA in blood. We converted them and we tested the primers. Even in this condition, all primer pairs were able to discern the differences between normal and tumoral DNA. Consequently, the goal of next month will be the application of this assay on real circulating tumor DNA from cancer patients that we are collecting in collaboration with the Neuromed and the European Institute of Oncology of Milan. Thanks for the attention.
Well done, Eugenia. Let's pass to Pasquale Creanza.
Good afternoon to everybody. My name is Pasquale. I'm first year PhD student, and my project regards a biotechnological approach to produce new protein bioplastics. Petroleum-based materials have acquired more importance in our lives. However, the wide use of these plastic materials is proved to be very problematic for the ecosystem, representing today one of the major sources of pollution. To overcome this problem, the main goal is to replace traditional polymers with plant-based biopolymers. The idea is to use an edible protein called phaseolin that represents the 50% of the vacuolar protein in common bean seeds. However, the native phaseolin is organized into homotrimer and are unable to form long polymeric chains. Thanks to genetic engineering techniques, it was possible the insertion of a cysteine before the 4C-terminal amino acid sequence of the protein. The cysteine can lead to the production of disulfide bridges that are able to form long polymeric chains between the single units of the phaseolin. The working hypothesis is to transform Nicotiana tobacco plants that are model plants with the engineered phaseolin. The transformation occurs within the chloroplast because its oxidizing environment can form the correct disulfide bridges. And once the biopolymers was produced, it can be used to make several products. To verify the presence of the biopolymer, an analysis on the level of aggregation was then carried out by comparing the native phaseolin with the engineered phaseolin, and we can observe their different electrophoretic pathway. With the electron microscopy, then we can observe its typical fiber structure. The biopolymer was then subjected to plasticization tests, and we can observe that it can form thin films that are transparent, insoluble, and elastics. So what I'm doing is the production of new protocols that simplify the extraction and the purification of the biopolymers from plants to reduce production costs and increase the yield. Thanks for your attention.
Very interesting, Pasquale. Now we can pass to Manar Isa. So we have a small problem in the presentation of Manar. Meanwhile, we will pass to the next presentation, Fabiana Fanelli. Allora, è uguale per tutto. Un attimo solo. Manar, can we have you back? It's okay, it's solved. Sì, sì, it's open. Sì. Pronta? È ready? From where?
Good afternoon, I'm Monora Isa.
Donatello.
I'm Monora Isa. My project is on optimizing rifampicin-loaded PLG nanoparticle through microfluidic manufacturing for successful meningitis management. under supervision of Professor Luca Casitari and Dr. Mattia Taboni. Brief introduction. What are the nanocarriers? Nanocarriers are colloidal systems. They are attractive platform for development drug delivery strategies. They are usually in nano size, which is below 1,000 nanometer, and they can be made with different materials. For synthesis of nanoparticle, there is a lot of methods for synthesis of nanoparticle, but microfluidic platform is highly attractive tool that can be help in synthesis of nanoparticle, and this is owing to its batch reproducibility, cost effective in both nanoparticle synthesis and screening. While we are processing the microfluidic technique, we use a microfluidic chip, which is be done using 3D printing technique. The type of nanoparticle I choose to use in this project is PLGA-based nanoparticle. What is the PLGA nanoparticle? They are biodegradable and biocompatible polymers particles composed of a copolymer of lactic and glycolic acid. What is lactic and glycolic acid? Is the PLGA. PLGA.
Can you please put the microphone in the
Yes. Okay. PLGA is approved US FDA polymer in drug delivery system due to its controlled and sustained release properties and has low toxicity and targeted delivery. The aim of my project is to develop PLGA nanoparticle using microfluidic technique, load PLGA with rifampicin, and enhance the ability of this PLGA nanoparticle to cross the blood-brain barrier to treat the meningitis and decorate their surfaces with antibodies. The methods. I start with preparation of PLGA nanoparticle using microfluidic technique. Encapsulate these PLGA nanoparticle with rifampicin drug, and then optimization the PLGA nanoparticle using design of expert software to choose the best formula, and then go through the best formula through characterization like TEM and SEM, DSC, and TGA. The results I have get till now that several PLGA concentrations have been tried, and as obvious, it's by increasing the PLGA concentration, it go to higher particle size and PDI. I choose the highest concentration of PLGA because it's still in the nano range, lower than 300 nanometer, and in the same time, by increasing the PLGA, it leads to high entrapment efficiency plus high stability. By comparing between two solvents, acetone and acetonitrile in preparation, acetone give me lower particle size and PDI, and by comparing about the method of evaporation between the stirrer and sample concentrator obtain better and superior results over the stirrer. Next step vision is to go and conduct in vitro drug release to evaluate the release of the drug, and then try to conjugate a specific antibody on the surface of the nanoparticle to improve the delivery to meningitis affecting area, and finally to go through cell culture technique for meningitis treatment using organ-on-a-chip, which is a 3D microfluidic chip that simulate a physiological activity and physical response of entire organ. Thank you.
Thank you, Manar. Fabiana, we can come back to you now.
Thank you, Riam, and good afternoon, everyone. My name is Fabiana Fanelli, and my supervisor is Dr. Giosuè Ballini, and the related topic. And the related topic of my PhD project is N-glycosylation and the insulin-like growth factor 1, IGF-1 signaling pathway, a promising therapeutic target for disease associated with disorder of N-glycosylation. Glycosylation is the most post-translational modification of the protein, and the deficiency of N-glycosylation and other glycosylation pathway leads to a heterogeneous group of inherited disease called the congenital disorder of glycosylation, CDG. And the clinical manifestation in CDZ are, for example, short stature, obesity, hypogonadism, and hypogenitalism. In my primary work, I studied the glycoprotein markers correlated with this disease, and we use the primary fibroblasts derived from childhood and patients that are affected by this CDG, and we evaluated the levels of glycoprotein markers like LAMP1, LAMP2, IGF-1 receptor, and IGF-1EA prohormone. And these glycoproteins are subjected, fibroblasts are subjected to a gradient gel for 15% SDS page and then transferred to a nitrocellulose membrane for immunoblotting. And we evaluated that for IGF-1EA, there are an increase of the band relative to pro-IGF-1EA, and for IGF-1 receptor, it is the same thing. And there is also a downward band for LAMP1 and LAMP2. But there is also Cohen. Cohen is a disease correlated with the CDG, but in this disease, the patients are characterized by VPS13B gene mutation. And to study the Cohen, we use another gel compared to gradient gel for 15%. This is a gel for high molecular protein, weight molecular protein. And we note that, for example, for LAMP1, there is an increase of the band. And for IGF-1R, there are the appearance of a second anonymous band. This is a good point for our studies future. So, thanks to this study, we can introduce a future study to confirm the correlation between N deficiency and the glycosylation pathway. So thank you for the attention.
Grazie Fabiana. Let's move to Chiara Giolitto. Questo per andare dietro, questo per
So good afternoon to everybody. I'm Chiara Giolitto. My supervisor is Professor Mirko Fanelli and my co-supervisor Amatori Stefano. And my PhD project aims to deepen the study of the biological effects of a new synthetic molecule belonging to the hydroxypyron family that is class of highly versatile molecules exhibiting interesting anti-proliferative activities against different cancer models. Among them, the most active one was found to be maltonis, being able to epigenetically reprogram the gene expression profile of NB4 cells, a representative model of acute promyelocytic leukemia, and through a genomic redistribution of several histone post-translational modifications. Moreover, of great interest is also a marked reduction of histone 3 lysin 9 trimethylation, presumably responsible of deconstructing effects towards centromeric and pericentromeric heterochromatin, leading to genomic instability and also an antiviral-like response. Considering the crosstalk between DNA, between histone modifications and DNA methylation, it's worth wondering the possibility of making maltonis work in synergy with other known epigenetic approaches. In fact, the citabin, there's a mounting evidence that suggests that the citabin that is well-known and the most widely used inhibitor of DNA methyltransferases in clinical practice, in addition to demethylating DNA, inhibiting cell proliferation and inducing cell apoptosis and regulating tumor immunity, also has a potential antiviral activity, which reinforced the idea of a possible synergy with maltodextrin. For this reason, in the first part of my PhD period, I evaluated the effects of maltodextrin and decitabine on NB4 cell survival in time course and dose response experiments, which highlighted a dose and time-dependent antiproliferative activity of both molecules. These results these experiments were also useful to define the optimal conditions for subsequent synergy studies in terms of concentrations and timing. Synergy was evaluated using biomedical research software, which quantifies synergism or antagonism through the definition of a combination index, which if equal to 1 indicates additive effect, if less than 1 synergism, and if greater than 1 antagonism. And if you can see, as you can see from the CE values of combined treatments in red, maltodextrin and DAC combined together resulted in moderate synergism. So in the first attempt to explain these preliminary results, we began profiling some epigenetic markers such as histone 3 lysine 9 trimethylation at protein level. And as you can see, surprisingly, while maltodextrin triggers a marked reduction of this histone mark, the decitabine seems to increase it in a time and dose-dependent manner. To conclude, the goal in the coming month is to deepen and to further characterize at epigenetic and molecular level these first observations, maybe through omics approaches such as RNA sequencing and proteomics. So I thank you for your attention.
Well done, Chiara. We can move to Gloria Gnonni.
So good afternoon, everyone. I'm Gloria Gnoni, and my supervisor is Professor Stefanetti, and I'm delighted to introduce to you my PhD project that is in collaboration with...
Excuse me, Gloria, can you please move the microphone?
Yes, sorry.
Thank you.
That is in collaboration with GSK Vaccine Institute for Global Health. So the aim of the project is to compare the humoral and cellular immune response elicited in animals by carbohydrate-based vaccine obtained with different technologies, because polysaccharides are the best established virulence factor of many pathogens, such as Klebsiella pneumoniae, that is the leading cause of neonatal sepsis and the main pathogen of my project. So the different technologies and platforms that I will use during my PhD are the classical conjugation of PS, so polysaccharide, to carrier proteins, moving to different technologies and new technologies as nanoparticles that have an optimal size for the antigen uptake by antigen-presenting cells, and also outer membrane vesicles as GEMMA platform, having the same advantages of nanoparticles and also the presence of self-adjuvants as pathogen-associated molecular patterns. Finally, we have a MAP system that is an innovative system based on the high affinity and non-covalent interaction between two components, biotin and rizavidin, in order to compare their ability to induce functional antibodies in different animal models against the two main polysaccharide antigens of Klebsiella, that are the K antigen, which is the bacterial capsule, and the O antigen, which is the external moiety of lipopolysaccharide. To conclude, we have a preliminary study with GEMMA platform in which mice were immunized with two different gemma displaying a different combination of K antigen and O antigen in their surface. And as we can see from the graph, we can demonstrate through ELISA the induction of a high antigen-specific IgG titer against all the four different antigens. So the two different K antigen in blue and the two different O antigen in green, and also the effectiveness of this platform as a putative vaccine candidate. Thank you for the attention, and a special thanks to my supervisors.
Thank you, Gloria. We can pass now to Muhammad Iqbal.
Good afternoon, everyone. I am Mohammad Junaid Iqbal. So my supervisor is Professor Michele Manota, and my co-supervisor is Dr. Anastasia Ricci. So my topic, my project, which is exploring therapeutic potential of ATM gene variants in ataxia telangiectasia. Ataxia telangiectasia, basically it is a genetic disorder, autosomal recessive disorder with progressive neurological decline. With immunodeficiency increased cancer risk, and also it affects cerebellum, which cause movement issues. So basically it is caused by biallelic mutations in ATM gene. ATM gene, which translates into ATM protein, is very important in different cellular pathways, such as DNA repair mechanism, cell cycle arrest, oxidative stress, and other pathways. Basically, it is a kinase-based protein, so it phosphorylates, and it activates different pathways. So when it basically it gets defective and it damages, so these pathways are affected by that. So there are various variants of ATMs which are found after, in the previous studies, we have treated them with glucosteroids. So after treatment with steroids, we have found that different variants were produced, which basically restores the cellular function. So we are studying some of those variants. The two important variants are ATM453 and another variant which we have computationally designed in our lab, ATM-SYNT. So it is synthetically designed. So these two variants we are basically studying right now. So we are just going to check that whether these variants dimerize, form dimers with our endogenous ATM or not. So this is our main objective. So if they form dimers, so it means that yes, we hope that it can restore the cellular function of the ATM protein. And then if it do so these we can introduce them through gene delivery system through nanoparticles into the human body. So basically, till now, we have introduced ATM variants into human fibroblast cell lines, and also checked quantified the proteins through and their dimer formation through Western blot. So till now, our results that we have got, that we have seen that successful dimerization through different antibodies we have checked through Western blot. So we have seen successful dimerization in both the variants that we have, variant 453 and also our synthetically designed variant SYNT. So as they form dimers, so now we are, and if you can see, not just with our endogenous ATM, but also there are some other proteins which are forming dimers with the variants. So now in future, we are going to study that basically how they function and if they can actually restore the cellular response, so we have a treatment opportunity for ataxia. And also, if there are other proteins which are interacting with those variants, so how they're interacting and how they can be helpful in the same manner. Thank you so much. And in the end, I would like to thank my professor and my lab mate, Gianluca. Basically, they are supporting me a lot throughout this journey. Thank you so much.
Thank you, Muhammad. Now we can move to Gianluca Morganti.
So good morning to everyone. I'm Gianluca Morganti, and I'm first year's PhD student. So a little introduction. Ataxia telangiectasia is a rare genetic disease characterized by neurodegenerative cerebellar ataxia immunodeficiency, and an high risk of developing cancer. The cause is a biallelic mutation in ATM gene, which encode for the same protein. The protein belongs to PIKK family and is serine kinase activity. So in the past, it has been observed that glucocorticoid treatment lead to a formation of smaller ATM variants, grouped under name mini ATM family. So some of these variants have been studied and characterized, and it has been observed that we're able to restore of some ATM function normally lost in AT variants. So our goal is to encapsulate ATM variants mRNA into a lipid nanoparticle and bind SCFE onto the surface of this particle. So this is because once in the bloodstream, the SV, the SCFE on the nanoparticle will engage the endothelial receptor, and this binding will promote a mechanism called a receptor-mediated transcytosis, which will allow the lipid nanoparticle to pass through the blood-brain barriers. And once the nanoparticle crossed the barrier, will be able to fuse with the neuronal cell and release mRNA into these cells. At the moment, we're working with two different CFV. One is an anti-ICAN1, and the other one is an anti-insulin receptor. We also added a short sequence of protein TAT in order to bind the SCFV into the surface of the nanoparticle. At the moment, we're cloning a CFV sequence into a PET22B expression vector, and after cloning, we transform the vectors into BL21D3 cell, and the protein expression will test by Western immunoblotting. So next step will be to cloning ATM variant sequence into a pmRNA vector in order to synthesize the modified mRNA for encapsulation and purify SCFV with an AMAC chromatography. And thank you.
Thank you, Gianluca. Now we can pass to Alessandro Nicois. I want to ask you, please, to keep it.
Good evening. I'm Alessandro Nicois. I'm from the first year of PhD on the 29th cycle. Today I will show preliminary data about the first part of my PhD project. My PhD project concerns about the study of microglia, orexin, and endocannabinoid system. And with today's presentation, I'll try to give you an insight about the role of orexin in this axis. So, orexin is a hippocampal neuropeptide that is produced by lateral hypothalamus. Bilateral hypothalamus, and as we can see from the central nervous system, there are many effectors that are contacted by the two isoforms of this receptor, OX1R and OX2R. So, orexin is produced as a pre-pro peptide, and through splices goes to this final form of orexin A and orexin B. Those two neuropeptides contact G protein coupled receptor, the aforementioned orexin 1 receptor and orexin 2 receptor, and by doing so is enhancing synaptic transmission via neuronal depolarization and a neurotransmitter release, causing various mechanisms to lead to synaptic plasticity regulation. But synaptic plasticity is also regulated by microglia. Microglia plays a key role in maintaining synaptic homeostasis by oscillating between two different or more different functional phenotypes. from an M0 homeostatic microglia could go to M1 pro-inflammatory or M2 anti-inflammatory phenotype. But microglia can undergo changes and enter in different states associated with pathologies. And in this case, it's called a DAM, disease-associated microglia. In particular, one of these DAM accumulate lipid droplets inside the cytoplasm and have pairs of the phagocytic apparatus, and is called LDAM. In this case, our lab in previous studies demonstrates that there is an increase in oxal levels in obese mice proven to be affected by the LDAM. So, to understand whether there is a link between the hyperuricinemia and the microglia impairment, we tried to develop cellular in vitro models to analyze it to a live-action cell scanning platform, the Zoom IncuSite. With this platform, we can follow and identify various biological signals, and in this manner, we try to understand what is going on. So we can try to see, for example, cellular oxidation or tracking mitochondria, as well as performing phagocytosis assay, for example, by pH RODO. pH RODO is a live-action dye conjugated with Escherichia coli bioparticles that emits in red when it's in contact with the acidic pH of the phagolysosome. In this case, we can see the BV2 cells treated with pH RODO to assess the phagocytic impairment due to the orexin A. So, specifically, we treated our cells with 0.3 micromolar of orexin A, and then we do the pH RODO assay showing a significant decrease in phagocytic activity respect of the control, and then we evaluate the level of lipid droplets accumulation by body P live dye to understand if there is a formation of lipids. In this case, there is an increase in lipid droplets accumulation. So, in conclusion, those results highlights the importance of the interplay between orexin A and microglia, taking the foundation from further research into therapeutical target to situation linked to microglia dysfunction. Thank you, everybody, for your attention. Thank you, my tutor Letizia Palomba and my co-tutor Gina Cristino, and thank you all for your kind attention.
Grazie Alessandro. We can now pass to Elena Perla.
Good afternoon, everyone. I'm Elena, and I'm working on the production of extracellular vesicles derived from red blood cells as RNA carriers. First of all, we chose RBCs as mother cells because they are readily available, their lack of DNA, and their non-immunogenic or cytotoxic nature, while we selected RNA as biologic to be delivered because of its several therapeutic applications, such as in rare genetic disease or gene expression modulation, large versatility, and long stability. In order to do that, we started from purified RBCs from fresh whole blood, loaded through an hypotonic dialysis, thus obtaining preloaded RBCs. These preloaded RBCs underwent a vesiculation by our new developed method called soft extrusion to obtain loaded RBCVs. According to MISEV 2023 guidelines, our EVs were then characterized by DLS, NTA, TEM, and flow cytometry. These results, not shown here, demonstrated that we were able to obtain a population of EV with a high yield, with a dimension of around 130 nanometers, and with a bilayer membrane, and also expressing glycophorin A, which is a typical RBC protein membrane protein, and also CD47, which is a don't eat me signal, preventing the early removal from the circulation. On the other end, our EVs didn't expose phosphatidylserine on their membrane, indicating damage. First studies showed that our EVs are easily taken up by cell models, and here you can see the uptake in UVEC, both with the flow cytometry and confocal microscope analysis, that resulted to be maximum at 24 hours and without any toxicity. Finally, we loaded our EVs with a specific microRNA, which is microRNA 210. And after demonstrating the efficient loading and the effective uptake, we were also able to demonstrate its biological effect exerted at mRNA, protein, and metabolic levels. At this point, we are now focusing on the loading of long RNAs into RBCs to obtain RBC EVs that will be used for the treatment of GAMT deficiency that will be, that it is a rare genetic disease. That's all, and thank you for your kind attention.
Thank you, Elena. Last but not least, Alice Sartini.
Good afternoon, everybody. I'm Alice Sartini, and my supervisor is Rossana Rauti. And this is my PhD project, so Advanced Carbon Engineered Organs on a Chip, Innovative Nanotools-Based Platforms for Brain Injury Repair. More in general, central nervous system diseases affect more than 3 billion people worldwide, and still there are very limited therapeutic options. So this makes them one of the great challenges of modern medicine. In many of these diseases, several, we can see an impairment of the neurovascular unit, which is a complex structure and its role is to maintain the homeostasis of the brain. And we can see it's formed by several different types of cells, such as endothelial cells, pericytes, astrocytes, neurons. And in particular, I'm interested in this structure in traumatic brain injury. Some of the challenges that we meet in this case is the for example, complexity of the structure, which makes it simply hard to study and makes it also in vitro models way too simplified for this specific study. The gold standard right now is animal models, which is still very far from being human relevant. And to overcome these challenges, an interesting recent development are organs on a chip, which allow us to have controlled experimental conditions and also conditions that are closer to the physiological ones when compared to classical cell cultures. And they are also very economical and also reusable. Another interesting focus of the last few years have been carbon-based materials, which are very versatile because of the very small dimension, the unique mechanical, thermal, and conductive properties. The objective of my project is to develop carbon-based materials substrate and to investigate its effect on the neurovascular unit cellular components, create MVU organs on a chip platforms, and finally, simulate traumatic brain injury and also observe the effect of this carbon-based material on the impaired crosstalk. In these first few months, we did develop our organs on a chip, our MVU organ on a chip. We can see different layers that will contain different types of cells, and everything will be connected to a microfluidic pump, and here you can see it in action in our incubator. And we did also individuate some interesting nanomaterials, such as graphene and carbon nanotubes, which have been shown to modulate neuronal excitability and synapses and so on. Here we can see how we use them as a substrate on primary neuronal cultures. which we also studied with electrophysiology. These are our preliminary results. And for the future steps, we would like to test them also on other cell types, co-culture, the various components in the chip, and finally, induce mechanical perturbation. Thank you very much.
With that, our first session is closed. Congrats for all the first year PhD students for their great work. Best of luck for your future work. Now we can leave the floor for the rector to give a short word on this great day.
Sul podio quale? Questo qua? Sì. No, qua, sì. Good evening. It's really a pleasure to be here with you this afternoon. I have to say that just I arrived a few minutes ago, and the level of the presentation was very impressive. But unfortunately, as you know, I'm an economist. I'm not in the field of biotechnologies and so on, and therefore I cannot enter into any specific discussion. But on the other side, let me say that this PhD day is very important, because it means that the University of Urbino has a focus on PhD programs, and we really we kept investing in our PhD programs, and I hope that our budget will allow to increase the number of fellowships to provide, especially to foreign students. We started a few years ago to open our PhD program to students from abroad, and it was very successful in several dimensions. One is that we open our way to do research, or to teach at the highest level, keeping into consideration the presence of also students that are not originally Italians. And I always thought that this is very important, to open up our minds, because it helps us to understand how to collaborate with other cultures and other ways to do research in a way. And for this reason, I would say that this day, the PhD Day, is very important, because again, put an emphasis, specific emphasis on the important role of PhD programs in our way of forming the new generations, the manager, let's say, the researchers, the managers of the future. Therefore, thank you to everyone who organized this event. I would say Ferdinando and Elena Barbieri and the rest of our colleagues. As we say, the list could be very long, but I always say that you always forget someone. So sorry if I didn't mention any other colleague, and especially to the students. So because I understand they're working very hard, and I really I hope and I wish you a very good luck for your future. Thank you.
Thank you so much, Rector. And it is special for us the opportunity to host you and to for your words, for your investment, for your sensitivity to the research and our efforts we will make for increase the opportunity for all the students to have the capacity, the projects, and so to increase the capability of all of us to better understanding why research is important in this field, but not only in this field, but also to create the capacity of the sensitivity of young researcher to enter in the society. So thanks again, Rector, and we take the opportunity to take a break or not? No, 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 no break. Okay. So, again.
Thank you, Prof, for the great opportunity you are giving to us as a foreign student. We hope to be as the highest level of the students you're having. Now, as I said, the first session for the first year PhD student is finished. I'm going to pass the floor to Fabiana that will be chairing the second session for the second year PhD students.
Thank you, Riam, for your presentation, and it's a pleasure for me to present my colleagues and friends of the second year of PhD program. And the first speaker is Bartolacci Alessia.
Good afternoon, everyone. Today, I like to show you some preliminary results of the investigation of the gut microbiota composition in 22 breast cancer survivors enrolled in the Sweet Movies project. Breast cancer is the most common cancer in women worldwide, and a healthy lifestyle, exercise, and diet can be critical factors in reducing the risk of relapses. The gut microbiota is an additional environmental risk factor in a patient with breast cancer, especially associated with metabolic dysfunction. Recent evidence has described the role of gut microbiota dysbiosis in the development of breast cancer. MOVIS project is a program that provides lifestyle intervention for women who have survived breast cancer, and based on the previous concept, we also included gut microbiota analysis. 172 women were enrolled in this project, 22 of whom, now 30, was part of the subgroup Sweet Movies with glucose and food habits monitoring. After enrollment, all the participants were divided into two groups. The control group received only suggestions about nutrition and exercise, while intervention arm had to participate in an aerobic exercise training for 12 weeks. Furthermore, we collected a stool sample from all participants at the baseline and after the lifestyle intervention. Then we extracted the DNA from the stool and we observed the gut microbiota composition through the next generation sequencing results. First, we perform relative abundance analysis at phylum level, and we find that there was a significant decrease in proteobacteria, a marker of dysbiosis, and a significant increase in actinobacteria. We performed also relative abundance analysis at the genus level, and we evaluated the alpha and beta diversity to assess the richness and the variety of gut microbiota. No differences were detected for alpha diversity, while there were significant differences for beta diversity among the groups from T0 to T1. As a future perspective, we aim to analyze all the samples from Sweet Movies participants to perform more complex statistical analysis and perform functional gene-targeted analysis of the intestinal bacterial butyrated producing community using real-time PCR. Thank you for your kind attention.
Thank you, Alessia, for your presentation. And the next speaker is Della Franca Chiara.
Good afternoon, everyone. My studies are focusing on early sepsis diagnosis. So, sepsis is defined as an organ dysfunction caused by the dysregulated host response to infection, characterized by the dysregulation of the immune and coagulation system, by immune suppression and tissue damages. Sepsis is a critical medical emergency, and early and appropriate management is crucial. So our attention is focusing on an early sepsis biomarker, the monocyte distribution width, an index of anisocytosis that quantifies the heterogeneity of the monocyte population. It is obtainable with the complete blood count with the differential leukocyte formula by hematology analyzer Beckman-Coulter, as well as cell population data that quantify and describe the cell population by measuring the mean volume and the standard deviation of volume, conductivity, and the scatter of the laser light. We are focused on neutrophil and monocytes. So this study aims to evaluate the changes in MDW and CPDs after the treatment of whole blood with the different concentration of Escherichia coli and Staphylococcus aureus, the most commonly gram-negative and gram-positive bacterial found in pathological sepsis, and of their associated pump, lipopolysaccharide from E. coli and the lipoteichoic acid from Staphylococcus aureus. And then we perform CBC at different time points. Our results show that both E. coli and Staphylococcus aureus induce a significantly time and dose-dependent increase of MDW, and in particular, E. coli has a stronger effect than Staphylococcus aureus. And this is confirmed by the effect of lipopolysaccharide that is significantly higher than LTA. Now I rapidly scroll the graphs about CPDs that you can better observe in my posters about monocytes, neutrophils, and these data significantly changed after treatment with our stimuli. CPDs represent cell size, internal composition of each cells, and cellular transparency. And here I summarized the results. E. coli induced significantly increased in monocytes and neutrophils volume heterogeneity, increased internal complexity reflected by vacuolization, and altered the nuclear structures, as we can observe in microscopical images. The changes with the Staphylococcus aureus treatment are similar, but less pronounced than E. coli. These results highlight the potential use of CPDs as early sepsis indices, since MDW is obtained from monocyte CPDs, but there is no analog for neutrophil, so it may be very useful to assess neutrophil CPDs. In conclusion, our results proved for the first time that live E. coli and Staphylococcus aureus, representative of gram-negative and gram-positive bacterial, induce a significantly different increase in MDW, greater for E. coli. And this is reflected by LPS and LTA behavior that promoted time-dependent increase in MTW, similar to those obtained with E. coli 10-8 and Aureus 10-8 CFUML, respectively. So our results support the clinical usefulness of MTW as early sepsis biomarker, but suggest possible species-specific differences in MTW variation. Thank you for the attention.
Thank you, Chiara, for your presentation. And now it's the turn of Fondi Stefani.
Thank you, Fabiana. Good afternoon, everyone. Today I'll present the study about extracellular vesicles modulation in response to high intensity and duration exercise. Extracellular vesicles are a major source of regulatory signals that play a key role in cell-to-cell communication. They have recently emerged as a potential tool through which the muscle communicates with other tissues and organs. Therefore, any changes in their presence levels or cargo composition could predict or detect local or systemic adaptation to exercise. So concerning this project, serum samples were collected from 19 marathoners, pre and post-race, and then processed by size exclusion chromatography, which divided each sample into 20 sequential fractions to isolate EVs according to their molecular weight. Extracellular vesicles were then characterized by nanoparticle tracking analysis for particle counting and size distribution, and by dot-blot assay for EV marker detection. To verify that SEC successfully isolated EVs from contaminants such as lipoproteins and proteins, BCA assay was performed for total protein content, and dot-plot analysis was performed with a positive control, tetraspanin CD63, and a negative control, apolipoprotein ApoA4. As we can see, the positive control CD63 is higher expressed in the central fraction, which correspond to the lowest protein concentration in the BCA profile, while the negative control ApoA4 is higher expressed in latest fraction, which correspond to the highest protein concentration in the BCA profile. In addition, NTA assessed the typical EV size and distribution in SEC central fractions. Dot-blot assay showed that CD63 expression remained unchanged, while CD9, which is another EV tetraspanin, and HSP60, that is a mitochondrial marker for cellular stress, are both higher expressed post-exercise. This data suggests that EVs could mediate the response, the adaptive response to metabolic stress, which is typical of high intensity and duration exercise. Moreover, the obtained results showed that there is an increase in CD9 enriched EVs subpopulation, suggesting that there is a post-exercise induced shift. Circulating EVs could therefore represent an innovative source of exercise biomarkers, which could give an helpful insight on the physiological activation state in response to physical exercise. For this purpose, further experiments will include mitochondrial DNA assay to check the inflammation activation state, myonomic analysis for the post-transcriptional gene regulation in response to exercise, and finally EV's biochemical analysis to check the redox status evaluation in response to exercise. Oh, sorry. Thank you for your attention.
Thank you so much. And the next speaker is Gentilini Veronica.
Good afternoon, everyone. My project adopts cellular models to study the prevention of tumor relapses. These models are 3D culture models in which cells grow on a semi-solid medium that you can see in the bottom of this slide. The growth of cells mimics the awakening and the proliferation of a single cell. That's what happens after a period known as cancer dormancy that can give rise to clinical relapse. Clinical relapses are very dangerous, especially for breast cancer survivors. A way to prevent clinical relapses could be the oxidation of tumor microenvironment. Indeed, high ozonide oil has been proposed as a therapeutic agent to oxidize the tumor microenvironment because its highly selectiveness and its ability in killing cancer cells. Moreover, epidemiological data shows that regular exercise can lower the risk of breast cancer recurrence, even if involved mechanisms are not yet known. That's why in this project we wanted to evaluate the effect of exercise and high ozonide oil on the growth of breast cancer cells. In our 3D culture models, we culture MDA, MB231 cells with a different concentration of oil, and we stimulate them with the exercise condition sera obtained from 11 breast cancer survivor women that underwent an aerobic exercise session. These samples were taken with the foundation of a LILT project. Samples were taken at rest and after exercise. We can see in the left part of this slide the individual effect of high ozonide oil. Especially low concentrations of oil reduce the 3D growth of cells. In the right part of the slide, we can see the individual effect of exercise condition sera samples that reduce the growth of cells in comparison to sera collected at rest. If we combine high ozonide oil and exercise condition sera, we can see that the reduction of growth of cells is more evident, and these results are statistically significant. We can conclude saying that the combination of exercise and oil could represent a promising approach in the prevention of breast cancer risk and mortality. For the future, we wanted to analyze the oxidative status of exercise condition sera samples to understand their synergism with the high ozonide oil derived oxidation. Thank you all for the attention.
Thank you so much, Veronica. And now it's the turn of Grossi Tommaso.
Good afternoon, everyone. My name is Tommaso Grossi, and today I will present my project entitled Effect of Bench Press Execution Velocity, Load, and Load Distribution of Perceived Exertion, and the number of repetitions performed. Resistance training is known as a strength exercise in which a muscle exerts their activity against an external load. When we prescribe resistance training, it's important to consider the ACSM guidelines, which are based on the FIT-VP principles, such as frequency, intensity, time, type, repetition, and so on. Oh, qui. Okay. However, the ACSM guidelines do not take into account all training variables. In particular, there is a high inter-individual variability in the number of repetitions to failure at the same percentage of 1 RM. The 1 RM is the maximal load that can be lifted in a 1 repetition. Moreover, there are problems related to an accurate load intensity selection in resistance training session, as well as there are additional elements that affect the exercise intensity, such as the execution velocity, range of movement, and rest time. To date, there are no studies that have evaluated how the barbell load distribution affect the exercise intensity. Therefore, the aim of our first study is to assess how different combination of load, different execution velocity affect the number of repetition to failure, rating of perceived exertion at fatigue onset, and the number of repetition at fatigue onset. The results of the present study showed that the number of repetition to failure was influenced by load and velocity. Specifically, a greater number of repetition to failure occurred with lower load and higher velocity. Regarding rating of perceived exertion at fatigue and the number of repetition at fatigue, they were influenced by load and velocity. In particular, higher loads produce a greater perceived exertion, but a fewer repetition at the fatigue onset. Furthermore, perceived exertion at fatigue and repetition at fatigue were greater when lower loads were used. Considering the result of the first study, we decided to delve deeper in the execution velocity during resistance training. Hence, we designed a second study that will be oriented on velocity-based training. Velocity-based training is a resistance training method that allows to prescribe resistance training intensity and volume based on the execution velocity as a feedback. Thank you for your attention.
Thank you so much, Tommaso. And now the next speaker is Imperio Marta.
Thank you, Fabiana, for the presentation, and good afternoon to everyone, and thank you for being present today. My name is Marta Imperio, and the title of my presentation is Monitoring Physical Activity Level in Breast Cancer Survivors using the Zanfei band during and after 6 months of lifestyle intervention. So in this first slide, you can see the experimental design about the MOVIS trial, and you can see that the breast cancer survivors, women, after the enrollment and after the baseline assessment, were randomized into 2 groups, the control group and intervention group. Both groups received the same healthy lifestyle guidelines regarding physical activity written by the American College of Sport Medicine, but the only intervention group followed 12 weeks of supervised exercise training program with incremental intensity from 14 to 70% of heart rate reserve and a duration from 20 to 60 minutes. Regarding physical activity level, at the moment we evaluated 34 breast cancer survivors women. In particular, we used wearable devices, a Zanfei band, in 3 times point. After 2 weeks of educational counseling of physical activity, after 3 months, and after 6 months. In this slide, you can see on the left the principal parameters which we evaluated about the physical activity level, and on the right, you can see the other parameters, such as anthropometric and body composition parameters, and the cardiorespiratory fitness, in particular the VO2 max. To conclude, I would like to show you some preliminary results. In the first table, you can see that the weight, body mass index, and fat mass decrease in both groups over time. In particular, both groups decrease these parameters after 3 months, and these improvements were maintained after 6 months. Regarding VO2 max, there is a significant time per group interaction. In fact, the control group did not change this parameter over time. In contrast, the intervention group improved VO2 max after 3 months and maintained this improvement after 6 months. Regarding physical activity level, you can see that physical activity duration, physical activity related energy expenditure, daily step and METs, and time spent in moderate PA changes over time in both groups. In particular, both groups at T0 point after our recommendation of physical activity reached the same physical activity level, a moderate level, But after 3 months, the control group decreases significantly this level. On the other hand, the intervention group improves significantly this level. After 6 months, both groups achieved the same physical activity level reached at T0 time point. There is also an improvement in time spent in vigorous PA, but it is only for a few minutes. Given the results, the supervised aerobic training program seems to be better than recommendation only to improve physical activity level and cardiorespiratory fitness over time. Thank you.
Thank you, Marta, for your presentation. And the next is Maestrini Sara.
So, good afternoon, everyone. I'm Sara Maestrini, and my PhD project concerns the drug discovery in human leishmaniasis, where human leishmaniasis is a complex of vector-borne parasitic disease caused by protozoa of Leishmania genus that affects a large portion of population worldwide, including the Mediterranean region, which is endemic for Leishmania infantum. The clinical spectrum of human leishmaniasis varies from cutaneous form to visceral form, characterized by irregular bouts of fever, enlargement of the spleen, and anemia. There is no vaccine against leishmaniasis, and the therapeutic options are limited and highly toxic, showing, moreover, emerging drug resistance. In this context, the aim of the project is to find new or already existing molecules that can be used as new therapeutic option for human leishmaniasis. So, the first molecule that we tested was the gallium-protoporphyrin, a protoporphyrin that instead of iron contains gallium, and because of the importance of iron for Leishmania metabolism, the molecule could offer the parasite a substance that is similar to iron, but ultimately harmful to the parasite itself. Moreover, we perform a phenotypic screening of an indole derivative library because there are experimental evidences that indole and azole scaffolds have anti-Leishmanial activity. So, the vitality of Leishmania major promastigotes and amastigotes, Leishmania infantum promastigotes, and the cytotoxicity against the human cells was tested after 72 hours of treatment with different concentration of the molecules through a MTSSA, which is a colorimetric method to monitor the activity of mitochondrial enzymes. Moreover, the mechanism of action of gallium-protoporphyrin was investigated through tests with hemine as a competitor. So we can say that gallium-protoporphyrin seems to be effective on both Leishmania major promastigotes and Leishmania infantum promastigotes. Moreover, then that gallium-protoporphyrin doesn't seem to be toxic for human cells, and that is able to reduce the rate of infection by almost 50% at a concentration of 50 micromolar. Concerning the mechanism of action of gallium-protoporphyrin, we can say that by adding gallium-protoporphyrin and hemine together at time 0, the viability of parasite increases significantly respect the control without hemine as the hemine concentration increases. Moreover, in this other type of treatment, we can say that the treatment of parasites with gallium-protoporphyrin for 72 hours reduced significantly the viability of parasites, but after the addition of hemine at different doses for further 72 hours, the viability of the parasite increases in a dose-dependent manner. In this way, we can conclude that gallium-protoporphyrin seems to have a cytostatic effect on parasites rather than a cytotoxic one. Concerning the phenotypic screening of the indole derivative library, we found the 3 most active compounds of the library, and although the most potent compound showed a moderate selectivity index, it may represent a lead compound of a new class of multifunctional indole-pyrrole hybrid active against leishmaniasis. Wait for you at my poster.
Thank you, Sara. And now it's the turn of Mariam Agna.
Can you please also tell me which one is the next and which one is the pointer? This one? Good afternoon, everyone. Am I audible? Yes. Okay. So this is Agna Mariam. I'm working with Professor Michela Battistelli on nutraceuticals compound. No. Okay. So one of the part of the project that we have done till now is the identification of chemical composition of curcuma caseae and also its photoaging potential in Hakat cell line. So basically, photoaging is premature aging of your skin due to UV radiation, which generally induce ROS species and also DNA damage in your skin. So it leads to wrinkle, loss of elasticity, and firmness pigmentation. So we have used curcuma caseae because it is traditionally being used, as you can see, as antioxidant, antimicrobial agent. But this spice has least use against UV radiation. So what's the basic aim of our study was to identify phytochemicals in these compounds and also to check its role as a photoprotective agent in Hakat cells. So basically, first we have extracted the, I can't, okay. First we have extracted this plant from the rhizome and then we identified its bioactive compound with the help of HPLC. We also did pre and post treatment or to the UV exposed Hakat cell lines. Then we analyzed ROS and mitochondrial membrane potential with mitosox assay and TMRE staining, followed by flow cytometry and electron microscopic analysis. So these were the research results that we have obtained. As you can see, where is it? Okay, as you can see here, cell cycle arrest that was caused by UV radiation, it was reduced by the curcuma treatment at different time period, like 24 hours, 4 hours like this. And same with the mitochondrial superoxide anion level that was also reduced by curcuma treatment in the Hakat cell that was exposed with UV radiation. We have also analyzed intracytoplasmic ROS level. It showed the same result that curcumin treatment has reduced the ROS level in the UV exposed Hakat cells. But in case of mitochondrial membrane potential, that was reduced by UV radiation. It was also restored by curcumin treatment. In case of scanning electron microscopic analysis, as you can see in the control diagram, there are intracellular junctions or connection that hold the cell. But when they are exposed to UV radiation, there is a apoptotic cell that and they form bulb-like cells. But when they are treated with curcumin at different time period, they restore their intracellular connection and their structure stability. So from all these results, we have concluded that this curcumin can reduce ROS level, and also it can improve mitochondrial stability and cell function. So we can use this black turmeric as a natural anti-aging project. And next studies, we will be also studying the nutraceutical compounds against the photoaging effect. Thank you for my team and also you for listening to me.
Thank you, Agna. And the next speaker is Montesi Ludovica.
Good morning, everyone. I'm Ludovica Montesi, a second-year PhD student. And with my supervisor, Dr. Rossana Rauti, I am presenting my PhD project titled Shear Stress and Neuronal Pathologies, Organ-on-Chip Model to Study Neurovascular Interaction. Cerebrovascular disease are disorders that affect blood flow and blood supply to the brain, causing around 9 million deaths each year. Alteration of blood flow are found in many neurological disorders, such as dementias, Alzheimer's, and Parkinson's disease. Fluid shield stress is a tangential force applied to the vascular endothelium and generated by the blood flow. Evidence suggests that normal shear stress, so the physiological one, enhance the blood-brain barrier properties, while the high value of shear stress, so the pathological one, led to barrier disruption, causing abnormalities of the vascular endothelium. Despite decades of research, the link between blood flow alteration and brain dysfunction remain elusive. This is mostly because of the complexity of the neurovascular unit, a complex structure composed of multiple cell types, the endothelial cells, pericyte, astrocyte, neurons, and microglia, and this, the scarcity of adequate models that recapitulate the neurovascular architecture. Actually, the most used technique is the cell culture, which is a static model, and the gold standard is animal, which is different from human being. With the advent of new technologies, a new platform with unique characteristics was developed, and it's called Organ on Chip. It's a platform that mixes the in vivo with the in vitro characteristic. Between the advantages of organ on chip, there is the low-cost feature, it's user-friendly, the possibility to outflow, and the possibility to reproduce the complexity of the human physiology. My PhD has three main aims. The first one is to develop a human-relevant NVU organ-on-chip platform, identify the metabolic interaction in the NVU components under shear stress, and target this interaction to diminish the neural dysfunction. Last year, I was able to develop the first microfluidic platform that is able to embed 4 different cell types, and we've developed the first NVU building blocks composed by endothelial cells, neurons, and astrocytes. This year, the second year, we developed the transepithelial electrical resistance, a tool that measures the resistance between the barriers, and it's a low-cost feature that we have developed. We test the transepithelial electrical resistance through CACO2 cells, a easy model, and we measure the resistance through 25 days, and after we apply the GTA to decrease to measure the disruption of the tie junction. We established the first setup composed by the microfluidic platform and the microscope and the peristaltic pump. And it's not working, but there is a video there. And we measure the calcium activity of the endothelial cells under the fluorescent microscope. And here in the graph, there is the peak of the calcium, the peak of the calcium, the spike of the calcium of the endothelial cells. Thank you. And thank you for your attention.
Thank you so much, Ludovica. And the next speaker is Piccioni Giorgia.
Good afternoon, everyone. My PhD project is focusing on the role of genus Enterococcus in the spread of antibiotic resistance in humans through the food chain. Enterococci are commensal of human and animal gastrointestinal tract, and they are also important opportunistic pathogens in the nosocomial area. And the aim of this research is to evaluate the actual risk of spread of antibiotic resistance through the food chain, specifically for 2 antibiotics, vancomycin and linezolid. Last year, we focused the attention on the major species, Enterococcus fecalis and Enterococcus faecium. In my second year, we focused the attention on the minor species because although they are not so important in clinic, they may play an important role in the spread of antibiotic resistance by sharing antibiotic resistant determinants to major species. The isolates were collected during different species of swine intensive farming, and 41% of total isolates resulted belonging to the minor species, specifically to Enterococcus gallinarum, Enterococcus caselliflavus, Enterococcus ire, Enterococcus avium, and Enterococcus durans. All resulted sensitive to vancomycin, while 8 resulted resistant to linezolid, specifically 5 Enterococcus gallinarum and 3 Enterococcus caselliflavus, both having 2 out of 3 transferable linezolid resistant determinants. The resistance isolates were used as donors in filter mating experiments to evaluate their ability to share lineage-resistant determinants to major species. All were able to transfer lineage resistance determinants, and specifically Enterococcus caselliflowers were able to transfer both of lineage resistant determinants. In conclusion, we can say that even the minor species can be dangerous for human health and for the spread of antibiotic resistance in humans through the major species. Thank you all for your attention.
Thank you, Giorgia, for your presentation. And now it's the turn of Riaz Jaweria.
How to move next? Okay, and the laser? Okay. Buonasera to everyone. My research project is virulence potential and antimicrobial resistance profiles of Salmonella species isolated during the 2 decades from different sources in the Marche region, Italy. The surveillance and monitoring of Salmonella by EFSA, they reported Salmonellosis is the second most reported gastrointestinal infection and is the most common cause of foodborne outbreaks in Europe. And there are more than 65,000 cases reported in 2022. And we can see here in Italy, oh my God. Okay. Here we can see there are more than 3,300 cases reported in Italy. European Food Safety Authority works in collaboration with ECDC, and they report data on the AMR of Salmonella. And they have seen that the highest resistance has been found against ampicillin, sulfonamides, and tetracyclines. Virulence genes are mobile genetic elements that are found on evolutionary pathogenicity islands, and they have the evolutionary features with the most important ones are SPI1 and SPI2. Here we can see the invasion is caused by SPI1 and intracellular survival and replications in SPI2. My main study aim is to assess the distribution and trends of antimicrobial resistance and virulence genes in human samples, in surface water strains, and in poultry wet food to establish a comparative epidemiological parameter on the pathogenic potential of this bacterium over time. My materials and methods, they include the collection of strains from a regional reference center for enteric pathogens, followed by phenotypic detections of AMR according to CLSI standards, and then genotypic detections, followed by statistical analysis. Here are my results. We collected 414 strains in the entire period of 2005 to 2022 from 5 provinces of the Marche region, with from wet food, 48%, 27% from human samples, and 24% from the surface water. Here we can see the trends of AMR that are rising trends in human and a declining trend in surface water, while an intermediate trend can be seen in the wet food strains. Here we can see the highest multi-drug resistance is observed in human strains, and here are the patterns that are most common patterns that are found in these 3 sources. Here we can see the prevalence of the virulence genes in 3 different periods, and we can see there are different patterns that were observed. While viewing at the frequency of the virulence genes, the most virulent genes are TOL-C, CYP-B, CYP-A, and SOP-B, while the least virulent genes were SPVB, TOL-C, SPVB, SOP-D, CYP-D, and SSAR. Here we can see the prevalence of the virulence genes in each serotype examined, and we can see the highest virulence was observed in S. diffimorium in surface water, while the highest virulence was observed in S. enteritidis in humans. Here we can see we have different patterns of virulence genes presence, like 36 patterns were observed in human, and 48 patterns of virulence genes were observed in surface water strains. Hence, an increased AMR and a wide distribution of important virulence genes over an extensive period, they can contribute to the evolution of the pathogenic potential of this bacterium and the outbreak and the spread of Salmonella. Hence, there is a need for efficient monitoring and management strategies in line with the One Health approach. Finally, I would say thanks for your attention, and a special thanks to my professor, Giulia Emiliani, and my co-supervisor, Professor Giorgio Brandi. If you have any questions, you are welcome to my poster. Thank you so much.
Thank you, Jaueria, for your presentation. And the next is Sordini Enrica.
Thank you, Fabiana. Good afternoon to everyone. I'm Enrica Sordini. My supervisor is Professor Amatori Stefano, and my co-supervisor, Professor Fanelli Mirko. My project is focused on characterize a new synthetic macrocycle molecule containing oxadiazolpyridine, synthesized from the chemistry laboratory of Professor Fusivieri, that combines interesting peculiarities of oxadiazoles and macrocycles. In the last months of activity, we deepened the presence, In the last months of activity, we focused on pathways affected by the treatment to understand the molecular mechanism of MOSTER inside the cell. Proteomic analysis, in collaboration with Professor Michele Menotta, show that mTOR signaling is the most significant pathway affected by the treatment. The other pathways are mainly associated with stress-like response. In literature, there is evidence that mTOR signaling regulates autophagy, studied and proposed as a new potential antitumoral strategy. In the light of these results, we deepened the presence of two markers of autophagy in order to validate proteomic results. We found that P62 and LC3B are upregulated in response to treatment, suggesting the involvement of autophagy in response to stress after treatment. P62 and LC3B, chloroquine was used as a positive control of autophagy. In the light of these results, we focus the attention on mTOR signaling. This pathway is often coupled with the MAP kinase ERK pathway, and their inhibition is associated with a cellular response to stress from different stimuli. These two pathways regulates MYC protein stability that has a key role in cellular proliferation. For this reason, we decided to investigate the MAP kinase ERK signaling. The results showed a time-dependent downregulation of ERK phosphorylation known to be associated with MYC protein stabilization. Western blot confirms the decrease of MYC as a consequence of treatment. At the moment, we are conducting transcriptomic analysis, and further studies will be needed to understand the molecular mechanism of MOSTER. Thanks for the attention.
Thank you, Enrica, for your presentation. And now it's the turn of Sparti Angelo.
Good evening to everyone. I will talk about new promising therapeutic target that is CD99. CD99 is a transmembrane protein expressed in various cell types and is involved in several physiological cellular functions such as cell differentiation, intracellular trafficking, cell adhesion, and more. Recent studies suggest that CD99 overexpression is observed in hematological malignancies and in particular in acute myeloid leukemia with FLT3 ITD mutation that is associated with poor prognosis. In recent years, in Diativa, we developed a fully human IgG4 monoclonal antibody targeting CD99 that has the ability to induce apoptosis in FLT3 ITD mutated cells, and in particular in the most difficult cells to reach, to target, and to eradicate that represent the reservoir of new leukemic clones. So, our primary goal is to understand how this antibody can induce apoptosis in these FLT3 ITD mutated and not in healthy blood cells by studying dynamics following CD99 recognition on the cell surface. We speculate that the therapeutic potential of CD99 doesn't reside in its expression or in its presence, but in its subcellular localization and, more importantly, in its interacting partner involved in tumor cell survival. So, to track the route of antibody CD99 complex after recognition on cell surface, we butynylated the antibody and we design an intracellular flow cytometry workflow to obtain quantitative information about the internalization rate of our antibody. And using two AML cell lines, one with FLT3 ITD mutation and the other one with FLT3 wild type, these methods allows us to quantify endocytosis process that is independent of FLT3 ITD mutation, even if apoptosis occur predominantly in FLT3 ITD mutated cells. Moreover, anti-CD99 this process involved only a fraction of anti-CD99, while a portion remains on the cell membrane. Treatment of a cell line with FLT3 ITD mutation with our antibody leads to a rearrangement of CD99 expression presence on cell surface, we change from homogeneous distribution to CD99 enriched zones after internalization. Although this process is independent of FLT3 status, the cellular context of AML cells seems to be a critical requirement. In fact, applying the same method, the same procedure to PBMCs isolated from healthy volunteers, we don't have significant antibody internalization. Moreover, anti-CD99 seems to recognize specific subpopulations on immune cells. Our hypothesis, compared to other commercial antibodies, our hypothesis is that our antibody recognizes a specific epitope that becomes accessible under specific special conditions. And this could explain its unique kinetic and its functional characteristics. In conclusion, this first step has uncovered a novel dynamic process involved in AML apoptosis. And this study highlights CD99 as a promising therapeutic target and allows us to focus the studies on membrane remodeling and subcellular localization to develop new therapeutic strategies and to deeper understand the acute myeloid leukemia strategy of survival. Thank you. A special thanks to Caterina Ciacci for confocal images, Barbara Canonico, Mariele Montanari, and Deborah Libetti. Thank you.
Thank you, Angelo. And now it's the turn of the last oral presentation for this second session. And the speaker is Torre Davide.
Thank you, Fabiana. So, my project is a comparative analysis of cellular immune response to different COVID-19 vaccination regimens. So the aim of the project was to compare different kind of vaccination profile, in particular ELA, AstraZeneca and Pfizer in the homologous and heterologous regimens, taking also in consideration the booster dose. Okay. That could be Pfizer or Moderna. So to evaluate the cellular immunity, we analyzed the memory B cell response and the T cell response. Okay, we started collecting PBNC from patients, and then for the B cell analysis, we labeled memory B cells specific to SARS-CoV-2 proteins, in particular the spike protein and the nucleocapsid. Then, by flow cytometry, we calculated the percentage of memory B cell. For the T cell analysis, we stimulated the PBNC with a peptide pool from the SARS-CoV-2 protein. And then we measured the cytokine production and the activation marker expression by flow cytometry. Here are some results. As you can see, all the vaccination regimens were able to induce a cellular immune response with no statistical significant difference. So we go further to correlation between the humoral and the cellular response. So we perform a Pearson correlation, and we found an interesting correlation between the T cell cytokine signature. So at the end, we also evaluated the hybrid immunity, and here you can see that in the heterologous group, there was an higher response in the people that have met the virus compared to the people that have been never infected. And the graph is showing the level of TNF-alpha. So to conclude, we can say that X vaccine regimen generate a cellular immune response, and also we found a positive correlation between T cells cytokine signatures. And for the hybrid immunity, we can say that the hybrid immunity influences positively the T cell response, in particular in the heterologous group. In future, we will go further with the bioinformatic analysis, and also we will want to test the T cell response induced by new prototypes of SARS-CoV-2 vaccine. Thank you for your attention.
Thank you, Davide, for your presentation. And that ends the second session of oral presentation. So I wish my colleagues best things and experiments for the future. And now we have the next chair for oral presentation of third year's colleagues. And it's a pleasure for me to give the floor to Veronica Gentilini. Thanks all, and thanks to Professor Lucertini.
Thank you, Fabi. Good afternoon again, everyone. It's a pleasure for me to introduce you the third year PhD students. The first is Abbas Faiza. She's online.
Would you please share your presentation?
Yeah, I'm just trying to share.
Okay.
Can you see?
We can't see it yet, but I'm confident it is arriving to our screens.
Can you see my screen, my presentation?
We can't yet see it, but I can see that you have shared your screen. So you should probably put your presentation on the screen if it is not there already. Okay. You have now to share your screen. Okay, we can see it now.
Yeah, okay, perfect. So, good afternoon, everyone. I'm Faiza Abbas, and I'm currently at Karolinska Institute, Sweden, for my period abroad. Here, I'm working with in vivo CAR T cells therapy, and basically, we are trying to explore various methods for delivery of CAR construct to T cells for improved T cells function in vivo. So, in vivo CAR T cells therapy, it is a cost-effective and time-reducing process. So, it involves genetically modifying T cells to express CAR that can kill cancer cells. So we can deliver genetic material to patient T cells using various viral and non-viral strategies. So here, the aim of the project was to basically to knock down a specific gene for improved CAR T cell function after in vivo generation. Something about methodology. So we knocked down a specific gene by shRNA. For this, first of all, we clone our shRNA into shRNA expression vector. This shRNA expression vector was then delivered to the T cells by various chemical and physical methods. Furthermore, we analyzed knockdown gene analysis by flow cytometry and by qPCR. Something about results. So here we can see that 0.5% of our Jurkat cells were positive for GFP when we transfect our Jurkat cells with lipofectamine. Then we further optimize our protocol for electroporation, and graph indicate that around 50% of our Jurkat cells were positive for GFP when we electroporated our Jurkat cells with 10 microgram of plasmid. Further, to see the knockdown effect at protein level, we did flow cytometric analysis, and the dot plots indicates that around 95% of our Jurkat cells were positive for our target protein. Transfection efficiency by electroporation was around 50%. Desired negative cell population of the target protein was just around 2%, as we can see through Q1 panel. Furthermore, we also analyzed our target protein expression by MFI, and here we can see that around there was some reduction was observed at by shRNA2 and shRNA3 construct as compared to untreated control. We also tried to see the knockdown effect at RNA level. And here we can see that around 50% of the target gene was knocked down by shRNA3 construct when our data was normalized to beta-actin. Around 50% of our gene was knocked down by shRNA construct 3 when gene expression was normalized to GAPTH. So in conclusion, we are currently applying non-viral strategies to investigate knockdown of a target protein. And we can say that physical methods are more efficient over the chemical one to deliver the CAR construct to T cells. We can see the knockdown effect at RNA level, but we were not able to achieve much promising result at protein level. So our future plan is to knock down a specific target protein by generating stable cell line. And this will be done by lentivirus transduction and integrase plasmid that can integrate one copy of gene per cell. So at the end, I would like to thank all my research team here at Karolinska and my colleagues in Italy for their wonderful support in this project. And thank you for your attention.
Thank you, Faiza. The next speaker is Abdallah Passant.
Good afternoon, everyone. I'm Passant Abdallah, and today I would like to invite you to imagine having the ability to peek inside the human brain. understanding how it works and seeing which areas light up when you're thinking, feeling, or dreaming. This capability is made possible by functional magnetic resonance imaging, also known as fMRI, that, unlike the other imaging techniques, allows us that visualize the structure of the brain, allows us to understand how different areas of the brain communicate, how we process emotions, and how the brain responds to a specific task. fMRI has drastically changed the field of neuroscience, so given that and given the results that we have already obtained with our ferrocarbotraloaded red blood cells, we are now trying to test them as potential structural anatomical MRI contrast agents and also as contrast agents for fMRI in collaboration with the University of York. Here on the right, you can see gradient echo T2 structural scan before the injection of our SPIO contrast agents on the top and after the injection on the bottom. This is an example of their use as standard MRI contrast agents. As we said before, fMRI enables to map cerebral areas of activity. We can visualize these areas by measuring the changes of the blood oxygen level dependent, also known as BOLD, but a better measure would be the cerebral blood volume. Basically, the BOLD signal is referred to the changes in the levels of oxygen in the circulation in the brain. When a group of neurons is active, it consumes more oxygen, leading to changes in the oxygenated and the oxygenated blood ratio. On the other hand, the cerebral blood volume is referred to a given amount of blood within a certain area of the brain. When an area of the brain is active, it consumes more oxygen and more nutrients, leading to changes in the blood flow, hence increasing the cerebral blood volume. Dov'è? Ah, ok. Non mi sembra. Ok, la prossima slide, grazie. Okay, so these are our ferrocarbotraloaded red blood cells that we use as contrast agents also for fMRI. We apply two kinds of stimuli, the whisker stimulation and the hypercapnia. And we base our measurements on the change of the cerebral blood volume. Why we did that? The cerebral blood volume is directly related to changes in the blood flow. On the other hand, the BOLD signal measures the changes in the oxygenation of the blood that can be also influenced by physiological parameters that are not directly correlated to neural activity. So the CBV provides more reliable data with a higher signal-to-noise ratio, and the BOLD signal is more susceptible to artifacts. So in our experiments, we apply the stimuli, we detect the BOLD signal as in a standard fMRI, and we see a positive signal with a small change. Then we inject our ferrocarbotraloaded red blood cells, we repeat the experiment, and this time we see a negative signal due to the presence of the iron inside the red blood cells. Given these two results, we are able to measure the percentage of the cerebral blood volume and to visualize the areas of the activity in response to our two tasks. La prossima, grazie. So if you want to know more about fMRI, you're welcome to my poster, and thank you for your attention.
Thank you, Passant. Okay. The next speaker is Agostini Rachele.
Good afternoon. I'm sharing my... Can you see the presentation?
Yes, please go ahead.
Good morning, everyone. I'm Rachele Agostini, and in this 3 year of the PhD program, I studied the impact of caveolin-1 overexpression in an in vitro cellular model of rhabdomyosarcoma. For the study, we employed 3 cancer cell lines, RD control cells that are transfected with an empty vector, and RD Cav1, FO, and F2 cells that are transfected with a plasmid that allows the overexpression of caveolin-1, which is an integral membrane protein that in this context promotes cancer progression. So given the strategic localization of caveolin-1 in the plasma membrane and given the large body of evidence about the pivotal role of extracellular vesicles in the context of cancer progression, the main question was which is the impact of this protein on the vesicular secretome in this cancer cell model. So 2 years ago, we started with the isolation of the 2 subpopulation of extracellular vesicles from these 3 cell lines. And then we characterize them by TEM analysis, NTA, and Western blot analysis. And we found that RD-Cav1 cells release a higher amount of extracellular vesicles compared to the control, and that the small extracellular vesicles released by RD-Cav1 cells do not express the tetraspanin CD9 and CD81, which instead are detected in the control, that are the typical small extracellular vesicle markers. These results have been then confirmed by flow cytometry analysis and extended to other tetraspanins by the proteomic analysis. Furthermore, we also found that also the lipidic profile appeared to be completely different, showing a clear clustering of RD, FO, and F2 cells, and also EVs, compared to the control. So this year, in order to further understand how can caveolin-1 critically affect the extracellular vesicle release and loading in this model, we decided to focus on the process of intracellular vesicular trafficking. And we found that LBPA, lysophosphatidic acid, that is a typical multivesicular body marker, is much more represented in RD, FO, and F2 cells compared to the control. This is true for many other proteins that are involved in this intracellular vesicular trafficking process, like Rab family proteins. And these results corroborates with the very preliminary results that I'm obtaining here in Lisbon for my visiting period abroad by the isolation and characterization of the endosomal compartments. Furthermore, we found that RD-Cav1 cells have less amount of lysosomes by the lysotracer staining, and that in these cells, the typical markers of autophagy, like ATG genes, are less expressed, suggesting that also the autophagy process can be altered. Lastly, this year we decided to directly test the effect of these vesicles on UVEC cells in order to assess their metastatic potential. And we found that both concentrated conditioned media and small EVs released by RD-Cav1 cells can increase UVEC proliferation and migration in a dose-dependent manner more than RD control cells. So, given these results, we can conclude that caveolin-1 overexpression has an impact on the intracellular trafficking, since it causes an impairment in the autophagy process and at the same time promotes endosome formation, and this leads to an increase in extracellular vesicle release with a completely different protein-lipid composition. Thank you for all attention, and also thank to Guescini Research Group.
Thank you, Rachele. The next speaker is Anjum Ruhi.
Thank you. Good afternoon, everyone again. My name is Ruhi Anjum, a third-year PhD student. As from the title, you can see that my research project is based on the CRISPR-Cas9 UBC gene knockout in gastric cancer cell lines. So, sorry. Yes. Ubiquitin is a highly conserved eukaryotic protein which has diverse role inside the cell, including cell signaling, gene expression, and according to the previous reports, it has been found that ubiquitin gets elevated, and by down-regulating two ubiquitin genes, mainly UBB and UBC, researchers have found that they can reduce the proliferation and cell viabilities in different kind of cancer. So what we try to check, we try to find out whether the same effects can be found in our gastric cancer cell lines or not. So we designed our aim. We wanted to create a complete UBC gene knockout in the two gastric cancer cell lines. One is primary and another one is metastatic. Strategies like that, the first step will be the designing of the CRISPR guide RNAs to induce the cut, then transfection of the plasmids with the guide RNAs into the GC cells, and then we have to validate our results. We have to validate the knockout or the deletion. So in the results, it takes some time, I guess, in switching. Sorry. So the first thing we checked, the deletion. So this is the genomic DNA PCR. And here we get the deletion bands. CRISPR works. So sorry. Well, I can show you. This is the knockout bands in the primary cell line, in metastatic cell lines, and these are the mocks. So the next, we isolated the cells, the CRISPR-treated cells. We grown the clones, and we have a further list of the experiments that some of them we perform, and some are in the list to in the queue. So then the next, we confirmed our genomic DNA knockout. We confirmed our knockout by genomic DNA PCR in the clones. What we observed that in primary cell line, we got a complete full knockout. These are the knockout deletion bands. This row shows the wild type bands, and this is the control, and this is the sample, the clones. So in primary cell line, the knockout was confirmed, very nice. But in metastatic cell line, we have the 4 clones only that shows the knockout, but partial knockout, not the complete one. So we selected only these 4 clones for further analysis, and all these clones for further analysis in both of these cell lines. The next, we checked the effect of the gene knockout on gene expression. So in primary cell line, luckily, as compared to the control, you can see all the clones have shown 0 reduction in the messenger RNA level. Also in the metastatic cell line, we have received a significant reduction in the gene expression level as compared to the control. We also checked total UB protein level by Western blot analysis, primary and metastatic. Different clone behaves differently, and some of them showed a significant reduction, just like one was not that much supportive. But in metastatic cell line, all the clones have shown significant reduction as compared to the untreated cells. Okay, so then the next, we tried to characterize one of the primary cell line. We performed cell proliferation and MTT. So you can see there different clones are showing different rates of growing and a 24-hour and 48-hour MTT analysis due to the effect of the knockout. So in comparison, I would like to, yes. In summary, I would like to compare the 2 cell lines that after the knockout, we got complete homozygous result in primary, heterozygous in metastatic. Complete reduction of UV messenger RNA in primary cell line, significant reduction. Western blot shown moderate reduction of all the clones, significant reduction in the selected clones. Further, we characterize the cells by performing MTT and all, and the results are supporting our current analysis. We have this list of experiments in future. We want to perform more analysis, and it will be interesting to know the effect of these 2 cell lines on the CRISPR-Cas9. And I would like to thanks to all my team, Professor Bianchi, Professor Maniani, Professor Rita, Francesca, Pietro, all the people, since this is my last PhD day here, so special thanks to the UniOrb community. Thank you so much for paying attention. Thank you.
Thank you, Ruhi. Now it's up to Bagherlu Nazanin.
Good afternoon. Good afternoon, everyone. The topic of my research is a study of the effect of clozapine on differentiating adipose and muscle cells. Now is better, okay. The topic of my research is the study of effect of clozapine on differentiating adipose and muscle cells. Clozapine as a second-generation antipsychotic drug is highly effective for treatment of schizophrenia, but also it's limited to patients unresponsive to other medications due to severe side effects such as weight gain, insulin resistance, and also metabolic syndrome. And also, sorry. Okay, the mechanism throughout that are not completely understood. In our previous studies, we carried out the effect of clozapine during adipogenesis differentiation, and also yes, no, because yes, I can also be here. Sorry. It's better, yes. Yes. And in our previous studies, we carried out the effect of clozapine during adipogenic differentiation in liposarcoma SW872 cells. And you can see here, clozapine reduced lipid droplets accumulation and also blunted the transcription factors of adipogenesis and also suppressed early NOX2 dependent ROS formation, exhibiting both NOX2 inhibitory and antioxidant effects, and also failed to scavenge mitochondrial ROS, and also following that leading to mitochondrial dysfunction. Starting from our premises, we investigated the effect of clozapine on mitochondrial biogenesis in early phase of adipogenesis, and also correspond to 3 days of differentiation. And also we extend the study to C2C12 cell line as a model for muscle cells differentiation and metabolic disease. And concerning to the first point, results show that clozapine slows down the PGC1 alpha and also mitochondrial DNA and also mitochondrial mass. And also following of this point, clozapine slowed down all of these events, and also clozapine inhibits the some protein of mitochondrial, some mitochondrial proteins such as CRX2, TOGC, TOM20, but surprisingly enhance the expression of specific components of respiratory chain complexes. In line with these results, clozapine in clozapine-treated cells showed high In line with this result, clozapine in clozapine-treated cells showed high mitochondrial activity by enhancing respiratory capacity and also boosted function of complex 2. Nothing special. What? No, thank you.
Sorry, I didn't understand what you said.
Nothing.
Okay,
special. Variation. Yes. Yes, yes. In conclusion, clozapine inhibits adipogenic differentiation, also blunts mitochondrial biogenesis, also increase mitochondrial respiratory chain expression, and also ATP synthesis, and this compensatory mechanism is accompanied by increased mitochondrial ROS production, leading to the mitochondrial dysfunction. And also, around the conclusion of C12 cells, clozapine, while it doesn't affect proliferating myoblasts, it's particularly toxic during differentiation. And experiments are in progress to further investigate these events and underlying mechanism. And thank you so much.
Thank you, Nazanin. The next speaker is Catani Linda.
Good afternoon, everyone. The title of my project is Field Assessment of Optimum Basilicum Essential Oil Potential Effect on Non-Target Soil Nematode Communities. The intensive agriculture has overexploited natural resources and altered the function of soil system. And this is mainly related to the abuse of chemical products used in agriculture for increasing qualitative and quantitative yields. Among the new Green Deal goals stand out the reduction in the use of pesticide. For this reason, it's important to find sustainable alternative to plant protection products. Essential oil can be valid candidate thanks to their features. And from literature, there are many evidence of their good effect as repellent against pathogen and parasite in vitro that affect crop or in preserving foodstuff. For this reason, we assess a research with in vivo experiment and that affect the soil beneficial fauna because in literature there is a lack of information. Monitoring the soil quality using a sustainable approach, it's possible thanks to nematode used as bioindicator. Thanks to their taxonomical feature and structural function, it's possible to calculate numerous ecological indices thanks to their abundance and also diversity. For this reason, we set up an experiment directly in field, collaborating by and hosted by an organic farm nearby. The experiment treat the chickpea seeds tan in the essential oil of basilicum at different concentration, with or without chitosan, and then the sampling was scheduled before and after sowing in order to have a batchy approach. The extracted specimens were then collected and identified at genus level. I acquired knowledge on taxonomy of free-living nematode at the University of Ghent in Belgium, and then all data collected were put into matrix for the following statistical analysis. A total of 44 genera belonging to 21 families were then identified. And here, just two graphs that represent the result of the research. It's possible to see that both factor, treatment, and period affect the nematode community structure. However, no significant differences have been detected in between functional indices, neither in treatment nor periods. And from the second graphs is possible to see that enrichment index and structure index emphasize this result because they evidence a lacking in significant differences for functional indices. So it's possible to conclude from this research that the use of essential oil in field, the Ocimum basilicum in particular, didn't evidence any significant disturbance in nematode community structure, and in particular in taxonomical and functional composition. But this is just one of numerous approaches that can be used for using and applying the essential oil in crop protection. Thank you. C'era un'altra slide dei ringraziamenti. Okay. Thank you.
Thank you, Linda. The next speaker is Ferrari Luca.
Hi to everyone. My name is Luca Ferrari. I am a PhD student in physical exercise and aging, and my supervisor is Professor Francesco Lucertini, and my co-supervisor, Professoressa Pogliaghi from the University of Verona. One of my main focus during these 3 years was to find a new and alternative approaches to promote an active lifestyle during aging in order to counteract the negative effect of sedentary behavior in elderly. In this context, recently we investigated the feasibility and effectiveness of a 6-month home-based resistant exercise delivered by a remote technological solution in healthy older adults. To doing so, we recruited 75 older adults, and we randomly allocated them in intervention and control group. The intervention group undergo a 6-month home-based resistant training protocol, which consists of 3 to 5 training sessions per week, lasting from 30 to 70 minutes. Each training section was composed by 8 to 10 exercises targeting the measured muscle groups, and of course, all the training protocol required only a minimal equipment in order to be able to training in home environment, so like a chair, table, elastic bands, and body weight. The innovative part of this project was the use of this technological solution, which was composed by a wearable inertial sensor and a dedicated tablet. These are the most interesting features of this technology. And one above all was the real-time feedback, visual feedback about the movement quality. So the software was able to provide a feedback, so the participants were able to correct themselves to modify the movement in order accordingly. Okay, so we assess the participant 3 times during the 6 months. we collect data about anthropometry and body composition, and also on physical function, such as balance or swayability, walking parameters or gait, and also on the lower limb muscle function, so data about the ability to express maximal strength and power. So the main outcome were that our approach results to be safe and feasible, because we did not record any exercise-related adverse event. We recorded also a good adherence for the first 3 months, despite during the second trimester this outcome was not so promising. And about the effectiveness, the intervention group displayed, compared to the control group, an improvement in all the walking parameters and also in the maximal expression of muscle strength in the lower limb. Taken all together, we can say that this low-cost and accessible approach should be considered whenever barriers to an active lifestyle are present. Thank you.
Thank you, Luca. The next speaker is Gubitosa Federica.
Hi, I'm sharing my presentation. No, I can't. Yeah, okay, now yes.
Now you should. Okay.
Can you see my presentation?
Yeah, of course. Thanks.
Okay, perfect. Okay, so good afternoon, everyone. Today I will briefly introduce the project I'm working on here at the University of Westminster in London. Briefly, an introduction. As we know, skin is the largest body organ that can protect our body from environmental and xenobiotic agents. Among these, the various environmental agents, UV radiation are the main factor that could initiate several skin disorders, from wrinkle to skin cancer. In particular, exposure to UVA radiation could increase the labile iron in skin cells, making them more vulnerable to oxidative damage and death. In particular, high concentration of iron in cells lead to a specific cell death called ferroptosis. This cell death is a type of programmed cell death involved in several injuries, including skin injuries. In this context, natural compound could increase the antioxidant and anti-inflammatory defenses of cells, protecting them from aging and photoaging. In this part of my project, 2 callus cultures from the eye pulp of an urcalipol were realized. After that, these calluses were dried and resuspended in 70% ethanol to obtain hydroalcoholic extract. These extracts were being chemically characterized and studied for their biological activity. In particular, from the chemical characterization, we found the presence in both calluses of high quantity of triterpenic compound. And according to literature data, this extract exerts a great anti-inflammatory activity. For this reason, to increase the stability and the activity of this extract, we decided to encapsulate them into nanoformulation and test then the anti-inflammatory activity. Specifically, the light callus extract was selected to be encapsulated, and the project will divide into the following steps. So first of all, we will prepare the callus extract, and we will encapsulate it into nanoformulation. After that, this nanoformulation will test into 2 specific inflammation models, a ferroptosis model and a wound healing model. In particular, focusing on the ferroptosis model, this model will create in this way. First of all, we will overload the ACAT cells with different iron concentration in order to understand if this concentration could induce any kind of inflammation in these cells without killing them. In parallel, an MTTSA on the hydroalcoholic light callus extract will be realized to exclude any cytotoxic concentration. After that, the extract will be encapsulated into nanoformulation, and we will evaluate the physiochemical properties of this formulation. After that, this formulation will be tested on ferroptosis ACAT cells in order to understand if this formulation could reduce the inflammation induced by iron. Research is in progress to optimize the encapsulation of the extract into the nanoformulation and to better understand the anti-inflammatory activity of this nanoformulation. Thank you for your attention.
Thank you, Federica. The next speaker is Masini Sofia.
Hi, hello everyone. I'm Sofia Masini and my supervisor is Alessandra Fraternale. And in our work we explore the effects of a thiol compound called I-152 able to release N-acetylcysteine and cysteamine on THP1 macrophages stimulated with LPS. And we evaluated the expression of pro-inflammatory cytokines, the transcription factors involved in the inflammatory response, then NLP3 expression and the ROS level. In particular, I-152 was tested at two concentrations, 0.25 and 10 millimolar, as a pre-treatment before the LPS stimulation. About the cytokine expression, we found that the low dose of the molecule finally modulated the expression of the main pro-inflammatory cytokines, both at transcriptional and secretome level, and on the other hand, the high dose of the molecule the high dose of the molecule strongly inhibited their expression. How we can see, the interleukin-1 beta and the interleukin-18 are cleaved in their mature form by a multi-protein complex called the NLP3 inflammasome. So we evaluated if the molecule could also modulate the expression of NLP3 protein, one of the subunit of the inflammasome. And we found that pre-treatment with the molecule at both concentrations could downregulate the NLP3 expression. About the transcription factors, we found that the high dose of the molecule affected both of the study's transcription factors that are NFKB and AP1 signaling, while on the other hand, the low dose was effective only on the AP1 signaling. And this can explain that the results about the cytokine expression, and also could suggest that NLP3 expression could be mainly under control of AP1 signaling. About the ROS level, we also evaluated the total ROS with the low concentration of the molecule, and we found that I-152 can downregulate the total ROS that are involved in the transcription factors activation, and also counteracted the mitochondrial ROS involved in NLP3 inflammasome activation, assembly and activation. Here are summarized I-152 possible targets involved in the inflammation response, and studied until now. And now in vivo studies are in program. Thanks for the attention.
Thank you, Sofia. The next speaker is Monittola Francesca. She's absent. Okay. So we go to Nazim Tayaba.
should I present? Okay. This next? Yes. Thank you. Good evening, everyone. My name is Tayyiba Naseem, and the title of my presentation is Role of Different Nutraceutical Compounds in the Prevention of Hepatic Steatosis. So what is hepatic steatosis? Hepatic steatosis basically occurs when we have nutrient overload due to sedentary lifestyle, which leads to accumulation of lipids in the liver. This accumulation of lipid, if remains untreated, leads to ER stress, mitochondrial dysfunction, and Kupffer cell activation. Kupffer cell activation results in activation of inflammatory pathways, leads to inflammation in liver, and the term is known as NASH, non-alcoholic steatosis hepatitis. NASH and NAFLD are reversible liver disorders that can be cured, but once they are ignored, they can lead to liver cirrhosis and hepatocellular carcinoma. There are several drugs that are in the market, but they have severe side effects like osteoporosis and other mild effects. So we are looking for, we are trying to design a drug that produce fruitful results, but with minimal side effects. Therefore, due to importance of nutraceutical compounds in the literature, we have found out that they can play a very important role in curing diseases with minimal side effects. We have shortlisted few nutraceuticals that and we will evaluate their efficacy, assess their safety, and we will study what are the mechanical pathways and mechanistic insights, and they compare their treatment, optimized dosage, and combination potential. So we extracted curcumin from the rhizome of Curcuma cassia, and then we used HepG2 cell line to induce steatosis in the cells. We used two types of solutions, solution 1 and solution 2. In solution 1, there was 66% oleic acid and 33% palmitic acid. But in solution 2, we used 4 different types of fatty acids, including oleic acid, allylic acid, myristic acid, and palmitic acid. We did pre and post curcumin treatments for 24 and 48 hours. We used different dosages of or different concentrations of curcumin to study at what concentration it could be effective. We used 1 microgram, 5 microgram, and 10 microgram of curcumin. Then we fixed the cells and analyzed them under light microscope and transmission electron microscope. So these were the results. Figure A shows the control, which shows very minimal lipogenesis because this is the control. In the figure B, you can see comparatively more lipogenesis or lipid droplets. This is the slide that shows the cells are treated with solution 1. Whereas in C, you can see the slide, these cells are treated with solution 2. So if you compare B with C, you can see that there are more lipid droplets as compared in C as compared to B. It means that solution 2 is more effective in inducing hepatic steatosis in HepG2 cell lines as compared to solution 1. Figure D shows the curcumin concentration 5 microgram and E shows 10 microgram. In the next slide, you can see the pre-treatment of curcumin with 5 microgram plus solution 1 with less lipid droplets. But when same concentration of curcumin was treated with solution 2, it shows more lipogenesis. In H, it's 10 microgram plus solution 1 and 10 microgram plus solution 2. This is the analysis that we collected through transmission electron microscope. It is also similar, like very few lipid droplets in the control. In B, solution 1, C, solution 2, and all. So what was our conclusion? That our results show that solution 2 that contained 4 types of fatty acids is more effective in inducing hepatic steatosis. So in future, we will be using solution 2 for our cell lines. And very low concentration, like 1 microgram and 5 microgram, did not produce any fruitful results. So next time, we will use higher concentration of curcumin from 10 microgram and onwards. In the same manner, we are also trying to investigate the higher concentration of curcumin and nutraceutical compounds such as coenzyme Q10 and artichoke extract. And we will study how they respond to the to controlling hepatic steatosis. I would like to thank Professor Dr. Pietro Gobbi, Dr. Michela Battistelli, and heart and soul of our lab, Dr. Sabrina Burattini, for their guidance and support. Special thanks to my colleague Rehan Usman for their collaboration and dedication. Thank you so much.
Thank you so much. The next speaker is Osman Riam.
Good afternoon, everyone. So my PhD project is entitled Synovial Fluid-Derived EVs, Impact on Endothelial Cell Function and Inflammation Progression. In my first year, we focused on collecting the synovial fluid from patients in collaboration with the Rizzoli Orthopedic Institute in Bologna. Then, to confirm the profile, the inflammatory profile of our patient as having low inflammation, high inflammation, and OA, we checked for the release of the pro-inflammatory cytokine interleukin-6. As we can notice here, we were having an increasement, a significant increasement in the high inflammation and OA patient, confirming our profiles. Furthermore, we moved to separate our vesicles. For that, we choose the ultracentrifugation. Once we had our vesicles, we moved to characterize them. And for that, we used the nanoparticle tracking analysis to quantify the particles, the Western blot to check for the positivity for the CD63, which is exosomal specific marker, and the TEM microscopy to check for the morphology and the size of our vesicles. This year, instead, we decided to check the effect of these synovial fluid-derived EVs on the modifying the endothelial barrier. For that, we used the HUVEC cells as a cellular model. First, we checked the internalization or the uptake of the cells for these EVs. As we can see here, we have an internalization of our vesicles after 4 and 24 hours of treatment. As well, we checked for the vitality or viability of our cells toward the treatment with different concentration of EVs. And we noticed that we have a decrease in the cell viability when cells were treated with the highest concentration of high inflamed derived EVs and OA derived EVs. Since the tight junction and adherent junction are two correlated with the endothelial barriers, we wanted to check whether these EVs can have like an effect on the endothelial barrier. So we checked for both adhesion molecule, the beta-catenin and the phi-catenin. We can notice here, as you can see, using the confocal microscopy, that in the control condition, we were having a continuous line all over the cell-to-cell contact area. Instead, in the low inflammation and the OA-derived exosomes, we were having a decrease in this fluorescence. This was as well confirmed by the quantification of the mean intensity fluorescence using the ImageG software. Furthermore, we checked in parallel for the MCP1, the expression of the mRNA to check if it is overexpressed in case of inflammation. And we interestingly noticed that in the case of low inflamed derived exosomes, we were having an increase by twofold for the MCP1 mRNA expression. Further studies to better understand the interplay between the synovial fluid-derived EVs, the adherent junction, tight junction, and the progression of the inflammation are underway. Thank you all for your attention, and for further information or curiosity, I'm always open to welcome you for the poster session. Thank you so much.
Thank you, Riam. The next speaker is Scardino Arianna.
Hello. Okay. Can you show me? Can you hear me?
Yes.
We can hear you, but
my presentation. Can you see my presentation?
We changed the order.
We?
Did you share your screen already?
Yeah, I wait. I retry. Okay. Can you show?
Okay, perfect.
Okay. Okay. Today I will talk to you about an environmental problem constituted by microbiological influenced corrosion, or MIC. This is a complex biogeochemical process involving interactions between microorganisms like bacteria, metal substrates such as steel, iron, and copper, and their related environmental conditions, and affect in particular the gas and oil industries. The microorganisms that mainly contribute to MIC are the sulfate-reducing bacteria, or SRB, that are anaerobic bacteria, and whose metabolism lead to the production of acids which increase the corrosion rate. But the major problem related to the MIC is the formation of biofilm, since growing in communities protect bacteria from environmental stress and dangers. The conventional treatment to prevent MIC include the use of chemical biocides, which are toxic and detrimental for the environment, causing high disposal costs. Therefore, eco-friendly antimicrobial strategies are highly desirable. In fact, my PhD project is focused on the use of essential oils that are natural compounds, safer for the environment, and exhibit broader biological activity. We choose cinnamaldehyde as a potential green biocide, not only for its no antibacterial properties, but especially because it is an inhibitor of corrosion, since forms a protective film on the metal surfaces. So we decided to test its activity against the SRB model species, the Sulfovibrio vulgaris, compared to a well-known biocide, which is glutaraldehyde. The minimum inhibitory concentration of the compounds was 12.5 microgram ml, resulting bactericidal against the Sulfovibrio vulgaris. Since the key element of MIC is due to the biofilm, I developed the Sulfovibrio vulgaris biofilm on a cover glass surface for 96 hours. And 72 hours old biofilm was found to be the best condition to evaluate the disruptive effect of the compounds. At this time, biofilms were exposed to serial cinnamaldehyde and glutaraldehyde concentration ranging from MIC up to 8 times MIC, and for their 48 hours. Both compounds caused a significant reduction in term, a significant disruption in terms of biomass, more of 85%, surface area, more of 80%, and average thickness, more of 45%, highlighting the potential of cinnamaldehyde as an effective alternative for controlling and mitigating MIC, showing comparable efficacy to glutaraldehyde. Thank you for your attention and enjoy.
Thank you, Arianna. Bye-bye. The streaming will now be stopped according to the speaker's request for confidentiality purposes. And the next one is Palma Francesco.
Good evening. Okay. Nowadays, it's estimated that more than 65% of microbial infection are due to the presence of biofilm, but this percentage is higher if we consider hospital environments. In the hospital, to maintain a healthy indoor environment, daily disinfection protocols are applied, but the presence of biofilm can reduce their efficacy, increasing the risk of healthcare-associated infection. As we know, biofilm are more resistant to the common disinfection procedure, And for this reason, the identification of alternative and efficient methods in eliminating them without leaving any chemical residues is fundamental and critical. Nevertheless, nowadays there are not standardized tests within Europe for testing the antibiofilm effect of disinfectants and of other disinfectant procedure. And so considering this, our aim was to evaluate the antibiofilm effect of UVC radiation, considering the most diffuse microorganisms in hospital environments. The first phase of our project was to evaluate the susceptibility of each trusted microorganism, considering both planktonic and biofilm form, and using different UV dose in both parts of this phase. After that, in the second part of the project,
I would to thank the teamwork and especially my supervisor, the Prof.ssa Barbara Canonico. Thank you very much.
Okay. I thank you all, and I would like to invite Professor Frangipani to conclude this session.
Thank you very much, Veronica. I would like to thank all the PhD students who have participated in these sessions. Thank you very much. It's been really great. Well, another one, collective one. It has been really interesting to get a glimpse of the diversity of research which is carried out in our department. And I would really like to thank Alessandra Di Giacomo, Federica Liguori for the live storytelling of this event on social media. Thank you very much. Also, all the students of Advertising and Organization Communication course and part of the communication staff that have worked very hard to make this day possible and to communicate actually what we're doing. And of course, I would like to thank Fabio Marangoni for the live streaming on YouTube. And it's the first live stream from this room, from the Aula Magna of the Campus Mattei. So it has a special meaning for us. Thank you very much. Okay, so now we can get more insight about the research at the poster session and enjoy the aperitifs. But before we do this, I would like to call you all here for a final picture as a reminder of this beautiful day. And I would like to remind you that at 7:30, there will be the Best Presentation Award. Thank you very much.